Sharing the entire screen, right, sir?
Uh, Instead of that, you can share your PPT.
To you, sir?
You can share your PPT.
Yeah, just a minute, sir. Yeah, is it visible, sir?
Yes, ma'am. Yes, ma'am. It is visible.
Okay, okay. Yeah.
Just we will wait for 2 or 3 minutes. Let our participant has to join.
Yes, yes, sir. No problem. So we'll just wait for 2, 3 minutes. Yeah.
Yes.
Hi, sir.
Yes,
Am I
sir. Yes, sir.
audible?
Yes, sir. You are
Your
audible.
voice today is okay. Yes, sir. You also audible properly today.
Thank you, sir. Thank you.
Yesterday there was some problem for your voice.
Yes, yes, yes. I check today. I check my connection. Shall we start, sir? Shall we welcome? Hello, sir.
Yes, you can start now.
First of all, one announcement. As per there are a lot of requests from our participant. So we will continue as per our schedule according to the mention in the flyer. So all the participant has to log into ATAL portal for giving the test. Your test timing will be 5:18 onwards. It is from 5:18 onwards as per your convenience. After finishing the valedictory function, you can give your test. Test time duration it is 1 hours. So first of all, finish all the sessions, valedictory functions, and then you can join to ATAL portal as per your convenience time. Within 2 to 3 hours, you can finish your test of 1 hour. Today you can finish your test. If any problem arises, then you can personally WhatsApp me. So let me introduce our today's resource person. So very warm welcome and very good afternoon to ma'am. Dr. Sharada Ohatkar ma'am serve as a head of electronics and telecommunication engineering department, and he currently working as a professor at MKSS Cummins College of Engineering for Women's, Pune. She hold a PhD from Savitribai Phule University, completed MTech from Vishwesvaraya Technical University, and completed his graduation from Babasaheb Ambedkar Marathwada University. With an illustrious career spanning of over 27 years of experience in the academia, she has made a significant contribution to the teaching, research, and innovation. Dr. Ohatkar has an impressive portfolio of 54 plus research publications in renowned journals and conferences, including those indexed in Scopus and SCI. She has authored 2 books, secured a patent, and currently guiding 5 PhD scholars. Her expertise lies in the cutting edge domains such as artificial intelligence, in wireless communication, cellular network, digital communication, signal coding, and combinatorialized optimization technique. A sought after speaker, she has delivered she has delivered a impactful lecture at both state and national levels, and regularly reviews manuscript for prestigious journals. So as a fellow of IIT, senior member of IEEE, and life member of ISTE, Dr. Ohatkar is deeply engaged with the professional community. Her exceptional contribution have earned her awards, including the Best Women Award for Innovative Technology in Teaching from Generation of Educational Impressions, Roorkee, and Distinguished Woman in Engineering from Venus International Women's Award, Chennai. These honors highlight her dedication to advancing the field of electronics and telecommunication through innovation, mentorship, and leadership. With this uh, welcome speech, I want to welcome today's resource person, Dr. Ohatkar ma'am. Over to you.
Yes, yes. Thank you very much, sir. I'm very much thankful for this ATAL session and to a very interesting ATAL topic, that is next generation communication. In fact, the research required in this topic of next generation communication is very much required. And also I can say the competition is less. And so that's why I congratulate all the participants who are here in the race where there is very least competition. but more work has been required in terms of research. I also like to thank the coordinator of the ATAL FDP, Dr. Kumar Mukane sir, as well as the co-coordinator, Professor Santosh Khare sir, for this opportunity. So, Khare sir, can I just start my presentation?
Hello, ma'am.
Yes, sir. Can I initiate the presentation?
Yes, you can start.
Yeah. So just confirm, sir, is it visible?
Yes, it is clearly visible. No
Yes.
issue.
Yes. Oh.
You can proceed.
Yes. Yeah. Thank you. Yeah. Okay. So again, congratulating all the participants. So just a minute, please. I'll just switch off my camera. Will that be okay, sir? Is it okay if I switch off my camera, sir?
Hello, ma'am.
Is it okay if I switch off my camera?
Yes, it's okay. No
Okay.
issue.
Yeah.
Whenever you want, you can on, off, as per
Yes,
your
sir.
convenience.
Yes, sir. Okay, got it, sir. Yeah. Okay. So let's start. So we are having time for 1.5 hours already. Okay, I'll try to make it compact up to the time and also some time for the question hour session. So with the introduction given of me, so you might have known that I've been working in communication field from last 27 years. Being an academician, I've been teaching the courses and also making a research on the same. So with that background, the recent communication, that is next generation communication, I'll be more focusing today on the topic of artificial intelligence in wireless communication. So here with this contains, that is here already with the different expert speakers who have interacted in the past 4 or 5 days. They might have given an overview of 5G and beyond. So I'll be just touching up on that slide, and only whatever is required for our future part that I'll be taking up. Then I'll be stressing more upon the need of the cognitive radio, how it is much more used and a critical enabler of our this thing communication networks today in 5G as well as 6G, and how we'll be able to suffice its goals. Then I'll be going for the algorithms of the cognitive networks, radio networks, and emphasizing more upon the cognitive engines. Then there are different processes which needs to be followed for the cognitive radio that will be explored, and what are the type of different artificial intelligence techniques which are being applied in all these processes we'll try to understand. Then the different types of artificial intelligence approach what have been used in cognitive radio we'll try to explore. And then I'll finally present my work in form of a case study, the work on cellular network as well as the cognitive radio network will be displaying on the scene. And then it will be followed by the question and answer session. So let's start with it. So with the overview of fifth generation and beyond. So we know that the fifth generation wireless technology, it represents the latest advancement in the mobile communication standard. And they are designed to provide a significant enhanced capabilities as compared to our 3G and the 4G requirement. We know 5G aims at higher data rate, low latency, increased device connectivity, and overall improved performance. We know we started from 1G, from people to people. Then we went from people to things. Now we are moving towards things to things. And this is where our area where you can have more work focused on 5G and 6G. So again, we started from analog voice, then we went toward digital message, mobile data, mobile broadband. Then the new radio came into picture, and now by 2030, 6G will properly percolate in India. And the new combination requirement for the 6G will be your enhanced mobile broadband, ultra reliable low latency communication, and also massive machine type communication. So this will be the 5G uses scenarios which the work is been going on at a very high speed. We know the key advancement in 5G. So I'll just compare what is required in the future development, that is 6G and beyond, and why I have taken up this as a topic for our discussion today. So for the future development in 5G, that is when we are expecting it maybe 5 to 10 years from now, the anticipated features are the 6G requires even higher data rate as compared to the data rates in 5G, that is gigabits level. Also, the delay must be reduced. That is, there must be reduction in more latency. That is, latency must be reduced less than 1 millisecond as in 5G. Also, this is a very important part, that is integration of artificial intelligence and machine learning. This will be prominently percolated because the communication will be now between things to things. Then the span, the frequency span also will be explored, which is not explored up to now. So terahertz band exploration will be done. So we'll be having more frequencies where we can satisfy the exponential increasing traffic in the present scenario. Then quantum communication is coming into picture. Also, continued focus on the energy efficiency and the sustainability is growing. That is the green communication that is again coming into picture. So to address these developments in 6G, which are already some of them are being achieved at a less rate in 5G, is the target of our today's discussion. So here comes our cognitive radio. So here I can say a cognitive radio is a critical enabler of 5G and the 6G goals. So what is a cognitive radio? So cognitive radio are the intelligent wireless communication devices that sense the environment, learn and use the algorithms to optimize and adapt the radio resources for efficient communication with a specified quality of service. We can also say a cognitive radio as a synergetic relationship for the intelligent wireless communication. So in order to have communication between thing to thing in the 6G scenario, the things itself must be so intelligent that they will be able to communicate with each other. That's why this cognitive radio or this type of a thinking and intelligence is required for the future wireless networks, the communication, 6G what I'm talking about. So to think about a cognitive radio again, so we can say a cognitive radio is a combination of two things, that is a software defined radio and the artificial intelligence. So we can call software defined radio as the sum of a combination of hardware and a software part of it, which we can call it to be as a body of the cognitive radio, and the brain or the mind, which it has, which makes the body to work. That is nothing but the artificial intelligence, and we are focusing on this mind or the artificial intelligence part of a cognitive radio, which makes all the goals of 5G and 6G feasible. So talking about how this cognitive radio is different from different radios. So here I am just put down three things, because we know a radio which is used to communicate, but how this cognitive radio is different from the other radios which are existent. So here I have taken three different radios: conventional radio, software radio, and the cognitive radio. In the conventional radio, we can totally say that it is a type of an hardware, so which is having a traditional RF design, traditional baseband design. It is having a fixed number of systems. Reconfigurability is been decided at the time of the design. And it may support multiple services, but it has to be selected at the time of the design. And yes, the important thing is that it cannot be made future proof, and it is not upgradable. So now rarely we are we are not using this conventional radio, but our grandfathers and so were really into that thing, that is using the conventional radio, tuning it and accordingly for communication. Then came the software radio. Software radio, as I can say, it is a combination or an extension of a conventional radio, added to it the software architecture. So it is a combination of hardware and software, I can say. Whereas here it is just a conventional radio is a hardware part of it. Reconfigurability provisions for easy upgrades in the software radios. There is a dynamic support and multiple variable systems, protocols and interfaces are available. It can be interfaced with the diverse systems, and the quality of service, a variable quality of service can be provided. And yes, it is future proof. So ideally we can say it is a future proof, that is it can be used, applied with some modifications to the future also, because as we know, in each after a couple of period, maybe 1 month or two, there is new things which have been coming up. Your mobile handset has been upgraded and you go for buying for a new mobile handset. So it is that way. So it must be compatible. We don't need to change the total this thing in mobile, but upgrades are which are coming up. So which can also say that it is a future proof. Okay. And also there is a upgrade mechanism, that is updates, and which are on the air mechanisms are there. So apart from this, what is required in a radio then? Yes, required is the intelligence, which we are now focusing on. So software defined radio along with the intelligence, we call it to be as a cognitive radio. So here this cognitive radio is aware about the environment. It is able to learn by itself. It can observe the surrounding, and then it can create the new outcome or new waveform on its own. It can also negotiate with the different interfaces. It can adjust the operations to meet the quality of service required by the applications of the environment. Then upgrade mechanism is, it can also upgrade the SDR mechanism. It is also having internal upgrades and also the collaborative upgrades. So now for a 5G and 6G, cognitive radio is a must, so that with that intelligence, it can operate to the different objectives which have been assigned for the future wireless communication networks. So with this understanding of different types of radios and what we are going for, so how this cognitive radio and the 5G and 6G, how it will be able to play role with respect to each other. Cognitive radio can be applied for the spectrum access, that is for the dynamic spectrum access. It enables the real-time spectrum sensing and the allocation problem. And yes, it utilizes the underused licensed and the unlicensed band. Apart from that, for the interference management, cognitive radio has really proved to be the best one for the application of 5G and 6G. So it senses the interferences and tries to minimize it in the dense network environment. Then yes, AI integration, that is intelligence imparted to the different SDRs and the different processes that we are going to see in the further slides. So cognitive radio's AI-driven adaptability, it aligns to the 6G intelligent networks to have a communication between thing to a thing. Yes, and also spectrum sharing, which is a very important part of work in 5G and 6G. So it facilitates the coexistence of the licensed and the unlicensed users. Licensed users, we also call it to be as a primary users, and unlicensed as the secondary users. So coexistence. So whenever the primary is not using a particular band of frequency, it can be sensed by the sensor, and accordingly it can be allocated to the unlicensed user, so that the communication will not be stopped. Yes, and the green, what we say about, which is nothing regarding the energy, that is the energy efficiency. So it optimizes the energy consumption in the massive deployment. So this is how we can apply cognitive radio in 5G and 6G environments. Now to start with the cognition cycle, that is cognitive radio, it follows the cognition cycle. That is the steps what it takes in order to complete the full execution of the different processes. First, it observes the environment with the help of sensors, then orients it according to the observation. It plans what different techniques has to be included, combined to have an outcome. Then it decides, the decision is being taken. Then it learns from its experience and then it acts accordingly. So it does not stop here. After acting, again it observes the next coming situation and the learning is being used again and again if the same situation is being encountered. Such as suppose you are traveling a road for the first time. So you'll be taking a long time, but when you are to be traveling that particular road the second time, it will be bit fast. You'll be able to know all the landmarks and trademarks when you will be going through that particular road. That if it is having a pit hole or a speed breaker or so, accordingly you will tune yourself with that learning. The same work is being done by the cognitive radio. So this is a very initial diagram of a cognition cycle, which was been first put up by Joseph Mithula in his IEEE Proceeding Personal Communication paper with the heading of Cognitive Radio, Making the Software Radios More Personal. So Joseph Mithula is a person who coined the word cognitive radio. Also, he is the person who coined the word software-defined radio. And then this particular cognitive radio, with his paper in 1999, the research was extensively taken up for all these aspects. So this is the diagram that I have taken from his paper. So here, if you can see, even though I say that after observe, we go for orient, then we go for a planning, then deciding, learning and acting, it is not so. Observation is done not only with the help of the sensor, but also with what was the previous state, what was encountered earlier. Okay, and then with that observation, it is been given to the orientation. And after orientation, it can also act. After orientation, it can decide, and also after orientation, it can plan. And with the planning, it will be able to learn. With the planning, it can decide. And with the new learning, it will be able to learn, modify its learning. So it is not a step-by-step thing. So it is like many inputs and outputs coming to the same process again and making it much and much better every time. So this is what is the cognition cycle with all these keywords: observe, orient, plan, learn, decide and act. After acting, again, this does not stop. Again, next observation is initiated and the learning is stored in the memory. And as per the situation encounters, that learning is been processed. So with this, we are having many use cases which can be enhanced or which can be modified, optimized with the help of the cognitive radio. Specifically, applications for the efficient IoT communication in smart cities. Reliable low latency communication is possible. Specifically now coming up are autonomous vehicles or electric vehicles also we can say. And yes, most prominently in the healthcare, that is remote surgeries are also possible with all these things. So this application, the cognitive radio, has really enhanced and given a very good application scenario for majorly for this use cases. So going ahead with the cognitive radio, the cognitive engine. So if you can see this particular diagram, here is my cognitive radio. In that, here is the space of my software defined radio. So which is nothing but a combination of software and the hardware part of it. And here we are having a cognitive engine. So where we are imparting the intelligence, or we can say this is a mind of a cognitive radio. So everything goes in hand, and accordingly, collectively, we call it to be as a cognitive radio. So we can say this cognitive engine is used to translate observations about the environment to actions with the different 6 steps what we have seen right now. And this cognitive engine design serves two simultaneous objectives. That is, it develops and applies the cognitive radio algorithms and it deploys the cognitive radio functionality. It's an important part of it. So without that, we also can call cognitive engine as a heart of a cognitive radio. So without the beating of the heart, also brain and heart, I'll say both of them, a major part of the body. Now going for the different artificial algorithms, intelligent algorithms, which are imbibed in the cognitive engine. So they are used for different processes. The first is the orientation process, and we'll be exploring in the further slide. The decision processes, learning processes, and the knowledge representation. We'll take a bit time for in understanding what are all these processes and which AI algorithms is used to implement these processes. In the orientation process, so we know that the cognitive radio is a technology that adapts dynamically to its environment by learning and making the decisions. So the one of the key process is the orientation. Okay, so it involves interpreting the radio environment to make meaningful decisions. That is the radio significance of observations. So here I refer to as analyzing the observed signals to extract the meaningful information. That is the cognitive radio can interpret multipath profile. That is how signals travel and scattered due to if there is an obstacle, maybe a tall building or a tall mountain, to determine if they match a known environment or the location. This process also tries to answer the question, does the multipath profile correspond to a known location? So here the multipath profile of a signal, it is unique to the location due to the interaction with the environment. So by comparing the observed profile with the stored profile, the cognitive radio determined if they are operated in a similar or familiar environment. And yes, the hypothesis testing. The process of orientation, it often reduces the testing hypothesis. That is, we know that is H0 hypothesis. If we say that the profile is matching to the known location, H1 hypothesis will be the observed profile which does not match. So here statistical and the probabilistic methods can be used to evaluate this hypothesis. So in order to implement this process, so there are algorithms which are being used in the cognitive radio. The first algorithm I can say, or one of them algorithm is the data mining. So where in data mining, it extracts the patterns and correlations from the large data sets of the signal observations. That is, it identifies the previous unseen relation in the signal profile. Then we are having another technique which is called as the hidden Markov model, which is having the probabilistic model. We can call it to be as a probabilistic model that deals with the sequence of observations. That is, if you want to see the strength of the signal strength variations, how it is varying, you will be what was it and how it is now, state, present state and what was the previous state. So that way you will be able to make it out in hidden Markov model. So it is used to identify the patterns in the dynamic environment, which we are able to most encounter in the mobile networks. And yes, this all of you know, the neural networks. So machine learning models is a machine learning model is capable of learning the complex relationship between the inputs and the outputs, between inputs and outputs that we know, and it can adapt to the new environment. And it does not require any explicit programming. Apart from that, yes, fuzzy logic. The fuzzy logic, it deals with the uncertainty and the approximate reasoning. That is, we have to approximate reasoning. That is, it helps to make the decisions when the observations do not fit clearly into the categories. That is, whether it is noisy or not noisy, and gradually increasing or decreasing the noise that we can be checked with the fuzzy logic. There is an interesting reasoning technique, AI technique, which is called as the ontological reasoning, which is based on the formalized knowledge representation. That is asking the question why. That is reasoning. So cognitive radio can reason about the relationship between the concept such as the signal types, protocols, and the environments. So with this, the orientation process in the cognitive radio, it involves interpreting the radio environment by analyzing the multipath profile and conducting the hypothesis testing. Then going to the different process, the another process which is called as the decision process. So the decision process in the cognitive radio, it refers to the mechanism by which the system interprets the current state of the network and selects an appropriate adaptation strategy. This process ensures the optimal operation while adhering to the constraints and the goals. Now, the purpose of this decision process, as the name indicates, it is mapping belief to adaptation. That is, the cognitive radio uses its understanding of a network. That is, what is the quality of the signal, how much is the interference, and how much are the channels available. It is using that thing to determine which particular strategy can be applied best to it, just by changing the frequency or adjusting the power level. Then it is also the purpose of the decision process is also guided by the goals and the policies. So whatever the decisions are made, it has to be made to fulfill the specific objectives. So the objectives might be maximizing the throughput or minimizing the interference. And also it is supplemented by the real world models. That is the models of the physical and environment and also the operational. It can enhance the decision making by providing the insight on how the network state evolves. So for this decision process, mostly heuristic algorithms are being applied. So we'll be coming to the heuristic approach further. But here heuristic approach is the approach where you are able to find out the near optimal solution without any computational cost. So in the heuristic approaches, which is mostly used for the decision processes, the very first approach used is the genetic algorithm. So it is inspired by the nature selection, and these algorithms iteratively improves the solution by combining the parents and generating a child which is better and better. Example, if we say for the cognitive radio, genetic algorithm is applied for optimizing the channel allocation. Then we are having a simulated annealing, another heuristic algorithm which has been applied. And it is similar to the annealing process in metallurgy to find out the near optimal solution. So here we can say mostly the power, that is power level to fine tune the power requirement from the transmitter side and also to minimize the interference, simulated annealing can be applied. Apart from that, we are having the local search method. That is, we are starting with the initial solution and incrementally refines by exploring the neighboring states. That is, here we can say adjusting the parameters like which type of modulation scheme to be applied in order to improve the performance, which becomes better and better as it goes ahead. The another interesting algorithm is case-based reasoning. So as the name indicates, it relies on the previous experience to make the decisions. That is, it must have a history of something so that based on that, it will be able to take a better decision. That is, suppose the same situation has encountered and a particular frequency band was used in order to transmit the signals, and the quality of signal has been received properly. So it'll be picking up the same frequency band which was being used earlier. And so in the similar situation, so this is the case-based reasoning. So this decision is what we can say is a center of the cognitive radio, and it enables to adapt to a dynamically changing network conditions. And heuristic gives a near optimal solution, if not the exact solution, but the approximate solution it is able to go with. Okay. So this was about the decision process. Now going to the learning process. So this learning process, it enables the cognitive radio to adapt to the situation that it has not encountered before. That is, we are able to learn something what we don't know what was previous, and that is what we call it to be as a learning. Okay. So now the key features of learning is that here the first point I have written is inform the radio of the unknown situations. If the situation is already known, there will be no learning. So there must be a mechanism to inform the unknown situations to the radio. Radio means the electromagnetic waves and with the help of which we are able to communicate. So when the current state of the environment does not match any previously known, then the learning process identifies this discrepancy and updates the radio's knowledge base. Then extension of the orientation. So we can say that this learning builds on the orientation process. How? That is adding a none of the above option for cases where the existing knowledge does not suffice, or and then expanding the hypothesis space to explore new possibilities, and also refining the existing hypothesis based on the upcoming or the new observations. For this learning process, data mining is being used. So here I'll be just giving an example how very it can be used. That is the extracting the usage pattern from the spectrum occupancy data. There the data mining is being used. The hidden Markov model. The next one is the hidden Markov model. So there is this transition between the hidden state and the suitable predictable state. So here estimation of the channel availability over some given time can be found out. Then yes, neural network is also used in the learning process, where the classification of the modulation scheme based on the signal features can be included. Fuzzy logic also can be is been applied in the learning process. That is managing the interference mitigation strategies in the interference of the noisy environment. Ontological reasoning is also used where linking the spectrum usage policies with the radio configurations, that is reasoning, it's there. Apart from that, case-based learning or reasoning is also been used regarding the work has been done on the power of the transmitted signal. Along with there is a one more learning technique which is called as the Bayesian learning technique. So as we know, Bayesian is nothing but understanding the prior knowledge. That is, it incorporates the prior knowledge and updates the beliefs based on the new evidences. That is, it can predict the future spectrum usage possibilities. So it is a part of a learning process. Now, this learning process, apart from that, it also has more learning tasks. That is, developing new actions for the emerging scenarios, then defining the new decision rules to guide the adaptations, incorporating new channel models for better performance predictions, establishing new goals as the system evolves, and also creating new internal algorithms to address challenges which has not encountered before or previously. So this learning process, it can operate autonomously It does not require any this thing direct input and direct output. It can operate autonomously and adaptively in the dynamic environment. And whatever it has learned, it can give to the next stage to make the outcome better and better. Then next is the knowledge representation. Here, the knowledge representation is here I have just put down as a issue, that is awareness about the environment. That is, cognitive radio needs to be aware of their operating environment. That is, which involves spectrum sensing, understanding what is the need of the users, detecting if there is an interference or not, and if there is any change in the environment. That is, if there is a rainy season, there is a summer season, there is a signal transmission reception quality is affected by that. And also it has to learn from each other. That is, it must be able to share the knowledge and learn collaboratively to improve the performance. That is, for example, a radio can share its spectrum usage by understanding, that is, interference history with the another. That is, if in this particular time this particular frequency is not we are not able to use it, it can inform this to the another user. So with this technical refinement, that is, thinking requires knowledge. So whatever it is thinking, it has to be put up in form of an language. So think here means that represent. This is I mean by representation. That is, for a cognitive radio to think, there must be a formalized way to represent, interpret, and exchange the knowledge. That is, we require a structural language, which is we will be able to enable reasoning about the environment, decision making, which is based on the knowledge, and also the insight, communication insight to the other radios which are present in the vicinity. So in order to have this knowledge representation, to have an effective knowledge representation, the proposed language, the one of the proposed language is radio knowledge representation language, which we call it to be as RKRL. So it is a domain specific language designed to encode and represent the information relevant to the cognitive radios. It captures the spectrum with the use of policies, the decision rules, what is the channel states, and so on. The another well-known knowledge representation language is XML, Extensible Markup Language. It is a flexible markup language and is used for refining the data. And it is easier for sharing and exchanging of information between the machine, or we can say between the radio, in a human readable and the machine understandable form. That is, we'll be able to represent properly the spectrum availability or the channel interference level with that. Another language which is been again used in different references is the OWL language, that is web-based ontology language. This is used for creating ontologies, that is defining the relationship between the different concepts, that is called as the ontology. It enables the radio to reason about their environment using a structured knowledge base. That is a relationship between the frequency band which has been used, which has to be used, which not to be used, and why. What are the different interference sources in that situations? Or what is the capability of the device? Everything. Okay. So by implementing the structured knowledge representation, cognitive radio can achieve a better awareness depending upon the different situation it has encountered. Learning capabilities can be enhanced, and a coordination or a cooperation with other radios can be made feasible. If the language is not known between radio and the humans, then there will be no exchange of information. So with all these four processes and the representation, AI approaches in the cognitive networks. Here I am putting down the different approaches which are being used in the cognitive radios for all these processes. So here I have just surveyed the different techniques which are being used. Here, artificial intelligence approaches, which we can divide it into a computational intelligence technique and knowledge-based system. In the computational intelligence techniques, we are having artificial neural network, support vector machine, meta-heuristic algorithm, hidden Markov model, or also we call it to be as a Markov model, multi-agent system, graph theory. In the knowledge base, we have fuzzy logic, case-based system, rule-based system, ontology-based system. Then in the present scenario, meta-heuristic algorithm is more explored because it is giving us a near optimal solution. So that solutions can be in form of a global technique or a set of solution, or there can be a single solution. So we are able to get a set of solution. Okay, so I'll go to that thing. First, in the graph theory, which is a knowledge-based system. Again, graph theory, the types of it are the auction game, Stackelberg game, bargaining game, repeated game. In the set of solutions for the meta-heuristic, that's where we want to go for a global technique, we are having this genetic algorithm. Then apart from genetic algorithm, we are having differential evolution, artificial immune system. We are also a very explored technique which is called as the swarm intelligence. In the single solution, we are having taboo search and the simulated annealing. And this swarm intelligence is really explored very much more in the cognitive radio applications, depending upon the performance it has been giving. So performing is improving day by day in with the help of swarm intelligence. So here in swarm intelligence, particle swarm optimization is there, ant colony optimization, artificial bee colony, cat swarm optimization, bacterial foraging optimization. So this is not limited. In fact, last maybe around 3 to 4 months, I have come across maybe more than 32 types of swarm intelligence technique. We'll be trying to understand the swarm intelligence with a slide or two in the upcoming slides. So here in the neural network, so all of you know the neural network, right? So it enables the intelligent and adaptive decision making. And it is having the ability to learn the patterns and extract features from complex data, which makes them to solve the challenges in the cognitive radio networks. So these are the challenges on the cognitive radio network. So I'll be just giving the examples in how the spectrum sensing is done in the type of a cognitive network, a neural network. In a spectrum sensing, CNN has been used. That is the CNN, that is a conventional neural network, which has been used and it can analyze the energy distribution in the frequency band. Also, recurrent neural network, RNN, is being used to predict the spectrum availability. Then neural network is also used in the spectrum allocation. That is a deep Q network, DQN, we call it to be as. So deep Q network, it can learn the best spectrum allocation policy. In the interference management, we can go with feed forward neural network. Feed forward neural network. So which has actually been implemented for addressing these issues of cognitive radio. Then for the signal classification, multi-layer perceptron, that is MLP, is trained on the signal data set to identify which type of modulation can be used, whether BPSK, QPSK, or any other type. Also, neural network is used in channel estimation and the prediction. Here we go for LSTM network. It predicts the future channel condition so that the scheduling of the transmission can be made much more easier. We are having hidden Markov model. In this hidden Markov model, again, it is a statistical tool. It's widely used in the cognitive radio networks for modeling the dynamic processes with the hidden states. Now, its ability to model the sequential data and hidden layers make it ideal for spectrum sensing. That is, with HMM, a cognitive radio predicts whether a channel is free or busy based on what it has observed previously and what is the signal energy of it. So we are able to sense the spectrum. In the dynamic spectrum axis, that is, if a secondary user predicts the likelihood of the primary user accessing that particular channel, it can be found out. Then in the interference prediction, predicting the transition, that is from interference level, whether the interference level is increasing or decreasing, going from low to high or high to low, that can be found out. In the spectrum mobility, the prediction can be done, that is predicting when a primary user will reclaim the channel, allowing the secondary user to switch over to another channel. So that can be done. That type of work has been done in the help of a hidden Markov model. Fuzzy logic, again, is a decision-making framework that mimics the human reasoning by handling the uncertainty and the impressions. Okay, so again, there are the similar applications where the fuzzy logic can be used in spectrum sensing, in spectrum sharing, yes, in power control. So how in power control fuzzy logic can be used? That is, if just suppose, for example, if the interference is low and signal to noise ratio is high, then we can increase the power slightly. And if the interference is high and signal to noise ratio is low, we can decrease the power significantly. Again, the decision making for the spectrum handoff, that is inputs such as the channel quality, how much time we are having, the mobility level, all these are evaluated to decide the optimal time off. Then the quality of service management, that is which particular application should be given a higher priority, medium priority, or the lowest priority. That can be designed by some fuzzy rules what are being designed for the same. So in this fuzzy logic, we are having, it is a knowledge base. It can, we are having different steps of it, fuzzification, inferences, and defuzzification. We are able to get an output accordingly. Then we are having interesting method, that is a heuristic method. So heuristic exploits a problem dependent information to find out a good enough solution to a specific problem. And meta-heuristic, they are like a design patterns, that is a general algorithm ideas that can be applied to a broader range of problems. So for an algorithmic complex or a time-consuming problems, heuristic technique can give a near optimal solution at the reasonable computational cost. And this heuristic technique are very much explored and getting better and better results. So how can the performance be measured? That is the quality of the best solution found, how much time is required to get there, the algorithm's time to reach an acceptable solution, robustness of the method, and so on. So these are the different set of performances, and this is what is required. So we are able to get an approximate solution, but a really a better solution, a mean of all the solution, and a practicable solution. We can also say in our normal words as jugaad. This is giving a very jugadu answer for the problems. And it also, every time it works very much practically. There are the different approaches to find out the approximate optimization solution, heuristic and meta-heuristic. And some of these techniques I have shown in the previous slide. Now, a very famous, what we can say, heuristic technique is the genetic algorithm, where we are having a population in a population. So, creating the initial population, taking the parents, going for a taking two parents, going for a crossover. After crossover, going for a mutation. After mutation, finding out the fitness. And if the solution is fit, then that fittest solution is selected, and after selecting it is again going to the population, and again it is refined and again. So this is one iteration, so that many iterations are there, and in each iteration you are able to get better and better solution. So genetic algorithm works on the principle of survival of the fittest. So this heuristic optimization technique is used for many applications in spectrum allocation, sensing, in power control, spectrum sharing, hands-off, radio resource management, and so on, which has been extensively used. I'll be putting down the results in our case study later of the genetic algorithms which I have worked on. Then we are having a particle swarm optimization. In the particle swarm optimization, it is a population-based optimization technique which is inspired by the social behavior of the birds and the and fish, we can say. So each particle in a swarm represents a potential solution, and the particles adjust their position in the search of a space based on its own experience and that of the neighbor. That is, suppose a birds want to, because the birds are in search of a food. So if one birds find out the food is present, so accordingly it sends some signal to the birds to come to that place to catch hold of the food item. So accordingly, you may also experience this thing number of times. That is, if one bird sees a food item, then in some fraction of minutes, there are so many birds which are coming at the same position picking up the food. So this is how this communication is being used for application in the cognitive radio. And we are able to find out the better solution. So here a moving can be used as a channel, remaining the position can be considered as a cell, and the swarm corporate, they exchange the information amongst each other. And again, this has been used for the similar applications as we have seen, but we are able to get a better result. Again, a comparison of PSO and J I'll be putting down in my case study work. We are having another interesting optimization technique, which is again a heuristic technique, which is the ant colony optimization. So it was developed in 1992, and again it is nature-inspired meta-heuristic algorithm, which is modeled after the behavior of the ant searching for the food. So again, this is again what we have encountered always. That is, if a food item is present and you're having an obstacle in between, initially the ants travel towards both the path, and the ants generate a pheromone. So which has been catched up by the ants which are coming after that, and it has been and that wherever the pheromone is strongest in that particular path, most of the ants go through that path. That is, it is able to find out the shortest path to reach the food. Okay, so this thing is been again taken into consideration, so how it can be applied in the cognitive radio applications. Again, yes, an interesting thing. Again, we are having another type of a technique which is called as the simulated annealing. So in this simulated annealing, probabilistic optimization algorithm inspired by the annealing process in the metallurgy. That is, you heat metal, then we are able to mold it, make it into different ornaments. So the properties of the metal is changed, it becomes more flexible, and after attaining certain temperature, the properties of the material changes. So that thing is being taken into consideration. So that process, that is heating and cooling it down, the defects are reduced, and it becomes much more usable. So that particular annealing is been simulated, information simulation is been done. And that technique is again extensively applied in the cognitive radio applications. Then similar to the simulated annealing, we are having taboo search as another meta-heuristic optimization technique, again, which is used to solve the dynamic this thing, combinational optimization problem. So it uses the memory structure, which is called as a taboo list, which prevents the algorithm from revisiting the recently explored solution and avoiding the local optima. So we are able to get the global solution, not only solution which is best in some given inputs. Again, it has been applied to the mentioned applications in cognitive radio. Now, after going through this understanding about the processes, the name of the algorithms, we are having different platforms on which we can implement the cognitive radio for different processes and operations. So the hardware platform for the cognitive radio implementation is the software-defined radios, which are in form of USRP, HAC RF, Blade RF, Line STR. Again, they differ in terms of operating frequency and the range of frequency. Then we are having test beds, cognitive radio test beds, which are CogWave, Orbit, Genu. This can be made use of. That is, these are the hardware platforms. Then we also have RF spectrum analyzer. Also, there are embedded development boards on which we can go with the cognitive radio implementation. And yes, antennas. Again, when we fabricate the antennas, so again, that is a hardware which can be used in the cognitive radio for transmitting and receiving the antennas. Apart from the hardware platform, we also have the simulation tools. The simulation tools, mostly here I have given the general purpose simulators, MATLAB. And for that, you will be requiring mostly the simulation communication toolbox. Communication toolbox, again, you are having different optimization techniques. So again, you are having that particular tool as an optimizer in the MATLAB as well. The work what I have carried out, I have totally used the MATLAB platform as a simulation, and I found it much more suitable for the work, and I was able to get very good results out of it. Also, you can take help of Simulink to go for addressing any of the problem. Apart from that, there's interesting GNU radio. This is much more better. Now presently I'm working on GNU radio and I'm finding it much more better than the MATLAB one. I'm able to have, if I compare GNU with the MATLAB, I'm able to get less delay. The memory requirement is also reduced and I'm able to get my results fast. It is much more similar to a Simulink, but I'm able to get what you can say simultaneous outcome at the same time with less programming. And designing the function is also much more easy. So it requires some C++ and the Python background for the same, for the GNU radio. We can also go for the network simulator 2, 3, but 3 is much more better for our 6G application, 5G and 6G. Then we are having Omnet++. Earlier, it was also called as a Qualnet and so. So that can also be used as a simulator for 5G and 6G. Again, the specialized tools for the spectrum management is the cognitive radio network simulator, MATLAB cognitive radio toolbox also you can explore. Then the machine learning libraries, TensorFlow, that is if you know Python, that is PyTorch, scikit-learn. And for the RF specific simulation tools, you can go with a Keysight, also NSYS software where you can design the antennas, HFSS design. You can simulate the antennas and you can fabricate that antennas, see its performance. Again, and also this thing, designing an antennas at the gigahertz frequency with higher gain, with wider bandwidth. Again, that can be a problem which requires to be solved. Okay, the size of the antenna also must be small. It must be have multiple inputs, multiple output MIMO type. So this also again is the research can be really explored with the help of ANSYS HFSS software. Then we can also integrate hardware and the software. That is, we can integrate the software defined radio with MATLAB or software defined radio with the GNU radio, and that is possible. This again I am working out with. Hardware in loop. This is also integration of hardware and software when you want to work with 5G and 6G. Okay, just a minute, please. Okay. I hope I'm audible, sir.
Yes, ma'am. Yes, ma'am.
Yes, yes, sir. Yeah. So with this, how much time we are having, sir? Okay, sir. So I'll be requiring some 15-20 minutes. Will it be okay, sir? Okay, sir, I'm continuing. Okay, with this, I will go to case study. So now deliberately I have written IES. It means that I'll not be discussing only one case study, but out of the work, what I have reported in the different papers, out of that, I'll be picking up 3 or 4 case studies, which are related to our discussion today of different techniques and the objectives of the cognitive radio. So here the study is related to the cognitive and the cellular network. So going towards my publication, if you can see the heading of the title of the paper, that is a heuristic for optimizing minimum interference channel allocation problem in cellular network. In the another one, it is a bio-inspired AI optimization technique to evaluate data rate and minimizing interference in cognitive cellular network. I want you to read the third one. Genetic algorithm and support vector machine. Here, support vector machine again is used for classification. So when I have combined GA with SVM, I was able to get a better signal to noise ratio in a dynamic channel assignment. Okay, so there you can also have a combination of classification with the help of machine learning algorithms, that is SVM. Then I have also applied bacterial colony optimization for evaluating the data rate in the cognitive cellular network. Also, bacterial colony optimization for evaluating signal to noise ratio, signal to interference noise ratio, SINR. Then also interference management for the hybrid channel allocation using spam intelligence, where particle spam optimization I have taken up. Apart from that, again, I am having a few more papers which I have published based on the topic what we have taken up today. So out of these 12 papers, I have picked up 3 or 4 papers, and that we will be discussing. So in the first case study, here the title of the paper was a heuristic approach for interference reduction in channel assignment of cellular radio network. So heuristic approach means a near optimal solution you will be able to get. So in fact, here I was trying to optimize the interference. That is, I want to minimize the interference. That is, I am targeting the channel assignment problem. That is, to investigate how channels need to be assigned and reused to minimize the communication interferences. Then here I address to propose a heuristic technique for a NP-hard, that is non-deterministic polynomial, that is channel assignment. We call it to be as a non-deterministic problem and hard problem in order to address. So for that, which will be able to lead to a minimizing the connection setup time, adapting to the changing load distribution. That is, if the number of users increase or decrease, what will happen to the allocation of the channels. Then maximizing the number of calls, that is without call drop, it must be able to be continued. And also to reduce the interference. So in presence of interference, how all these things can be carried out. So for that, I have taken the benchmarks, the different benchmarks here you are able to see. I have taken this 49 cell benchmark, Kunj 1, Kunj 2, Kunj 3, and Kunj 4. So what these benchmarks are saying that these are the number of cells, these are the number of channels available, and this is the traffic. This 30 is the traffic in the first cell, 60 is the traffic demand in the second cell, 15 is the traffic demand in the third cell, and so on up to 60 is the traffic demand in the 70th in the 49th cell. And for that I have measured call blocking probability and how much time it takes to reach to a proper assignment. Similarly, for the other benchmarks also, which vary in the number of cells and the number of channels. Again, I have addressed how much is the interference. In the cellular network, we are having co-channel interference, co-site interference. Again, the signal to interference and noise. Which indicates
Hello, ma'am.
Hello. Hello, ma'am. Hello.
व्हिडिओ पण दिसत नाहीये का सर?
Yes, yes, yes. Now it is audible.
ओके 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 सर, जस्ट अ मिनिट. कुठल्या स्लाइड पासून?
When you started the case studies.
Case studies. Okay, sir. I may require 5 more minutes, sir, then. Will that be okay?
Yes, 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 yes. Definitely.
Okay, sir. From this slide, sir?
When you started your case studies publication and then you elaborating the first case study.
Yes, sir. Okay, sir. Yeah. So I'll be not reading it again, but I'll be putting down
Yes,
some
yes.
of my work. Okay, so these are the 6 papers based on that. And if
Actually, your PPTs are not visible.
PPT not visible, sir. Okay, just a minute. Okay. Do you want me to reshare it again?
Yes.
Okay, just a minute, sir. I will stop sharing and reshare it again, sir.
Yes, yes, yes.
Yes, yeah, just a minute, sir. Is it visible now, sir?
Yes, yes, yes. Now it
Okay.
is visible.
Yes, sir. I'll be doing it again. Okay, sir. Okay, so with the case studies, if you want to go through the different work what I have done on the topic what we're discussing today, you can refer to my Google Scholar profile. In that, you'll be able to get the total work what has been done on the different algorithms and applied to the cognitive radios. Okay, so here I have put down 12 of my papers, the published papers. Okay, so we were talking about the first case study. What here I'm putting it down for a brief discussion is a heuristic approach for interference reduction in channel assignment of cellular radio network. So here, how the channel assignment problem can be solved in present with minimum interference. That is the problem which is tried to be tackled. And here I have proposed 3 heuristic techniques, which we call it to be as a NP, solving the NP hard problem, which is nothing but the channel allocation problem. This is what I have tried to address. And in that, the time requirement must be less for the channel allocation. It must be able to adapt to the different demands, the demands, the low or high demands. Then maximum number of calls, that is maximum signals must be connected, and also the interference must be minimized. So in try to address all these objectives, I have selected some heuristic method. Again, why we are selecting that methods that must be explored earlier, then it is required to be implemented. So here, in order to carry out this work, I have considered a different benchmarks which were given in the literature. That is here, it is 49 cell, 1, 2, 3, 4. So what are these benchmarks which tells that how many cells are to be considered, how many channels are there, and the traffic demand says that how many demand is there in each cell. So we'll be having 70. So we'll be having 70 such demands. So this will be for the first channel, this will be for the second, third, this will be for the fourth channel, and similarly, this will be the demand for the 70th channel. Similarly, we are having the cells and the channels for the respective benchmarks, and these are the demands, which are considered as a benchmark. And then what I have measured, call blocking probability, that is the number of call dropping is being measured, the time to get an outcome is measured, the interference, that is the co-channel co-site interference is being measured, also the interference in form of signal to interference noise ratio, SINR, that is also measured. And all of them is done with the help of three algorithms, heuristic algorithms, that is genetic algorithm, particle swarm optimization, and ant colony optimization. So here, this is a plot what I was able to obtain with MATLAB, where I have just depending upon the requirement of this benchmark, here it has been designed. And this is what I was able to obtain the channel allocation matrix with the help of genetic algorithm. So here these are my 49 cells and here are my 70 channels. So in my first cell, now these dots which indicate that in that cell this particular frequency is being allotted. Okay, and there we are putting also a constraint that the separation between the frequencies what have been selected must be how much. So same frequency cannot be used in the adjacent channel. So that also that constraint is been given to it, and accordingly fitness function of it is been designed. Then call blocking probability of all of them is measured. Again here with the existing work of genetic algorithm, that and then I modified it with the help of genetic algorithm by designing a fitness function and converting a binary population into a non-binary population. And with a proper designing fitness function, I was able to get a better outcome as compared to the previously work of with genetic algorithm. Then just in order to overcome the limitation of genetic algorithm and make to have a better outcome, I worked out with another heuristic algorithm, which is particle swarm optimization. Again, I was able to get a better outcome with PSO. Then also and I was able to find out that the computation time is increasing in PSO. So in order to check out this computation time, I worked out with ant colony optimization. And then I was able to compare all of them together. So which particular algorithm is better in order to combat what particular problem in the network. So with respect to the call blocking probability, I was able to make out that with particle swarm optimization, minimum number of calls were blocked. That is, call blocking probability is least with PSO as compared to genetic algorithm and the ant colony optimization. And my work was better than the previously published work for the uniform and for the non-uniform traffic demand. Then regarding the computation time, I was able to find out that ant colony optimization required less time, whereas T increases as the demand increases in genetic algorithm, and with particle swarm optimization, it's almost uniform time for the increasing traffic demand. So that is what I was able to make out. Then I worked out with another benchmark, that is a Kunj 4 benchmark, again with the given number of cells and frequency. The channel allocation matrix for that number of channels and frequency was plotted. Then in order to address the interference level, what I have taken is that these circles indicates the number of demand in that particular cell. And if there is some interference, so this too, the link will be present for the interference. and there will be another link which is present for the interference. So the red colored link indicates that it is a co-channel interference, and the green link between the 2 points indicates the co-site interference. So counting how many interferences are there, and this is nothing but it may be using the same frequency, or the reuse distance is less, which is causing the interference. So after finding out with all these three algorithms, GA, PSO, and ACO, for the different benchmark problems, I was able to find out that with ant colony optimization, my interference is minimum, least. It is least for the given benchmark problem. Okay, but actually, if the in the benchmark problem, if the number of demand is more, number of cells are in thousands and lakhs, and frequency is that, it may not operate in the same way. Again, that I experimented it further. But with few cells and few frequency, this works out to be the best option for the optimization in order to reduce the interference level. Then signal to interference ratio, I tried to find out. Then that is the, and I have taken up a propagation model, that is a Hatta propagation model. So considering this Hatta propagation model, I've designed the expression for the signal to interference ratio. And then I worked out with previously worked genetic algorithm. Then I worked out with modified genetic algorithm, particle swarm optimization, and ant colony optimization. And here again, I was able to make out that particle swarm optimization, that is a blue colored one, is giving me a better signal to noise ratio as compared to the previously worked out. This black colored one is the previously reported work, and with my work, it became better and better. Okay, so in the another case study, which was related to the single solution, that is simulated annealing and the taboo search. So here, while presenting this paper, they have interestingly asked for an abstract picture, and that was really, I really found it much more interesting. So which would give a proper glimpse of what you have done it and what is your outcome. So here in this paper, I worked out with genetic algorithm, simulated annealing, and in my next paper, I worked on taboo search. But here I have not put down that results, but you can refer through books. And this is for the cellular network. I applied both of them, and I optimized the channel allocation problem. Okay. Then from that, I got a channel allocation matrix. And from that, I found out the interference. So the red color indicates the co-channel and the green color indicates the co-channel, co-site interference. And that I was able to find out from this algorithm, simulated annealing and taboo search. Okay, then here I worked out with different set of benchmark problems, what were given. Again, in the similar case, what we had it, number of cells, then we are having a compatibility matrix. Okay, so these are the demands. Compatibility matrix means which there must be separation of what frequency and which particular cell must be allotted or not allotted. So that is called as the compatibility matrix. So with different compatibility matrix and with different demand vector, considering that simulated annealing and taboo search were worked out with, and then this results, I compared simulated annealing with genetic algorithm, and then I was able to get the results that simulated annealing is better in which particular type of benchmark. I would suggest you to go through this paper for a detailed explanation of the same. Then going for the work in the exact cognitive radiocellular network, these were the different techniques which were applied. And the scenario for the cognitive radio network is a bit different as compared to that of a cellular network. So here we are having the licensed users and we are having unlicensed users. So unlicensed users will be allotted when licensed users are not using the resources which are available, and how you can go for it. So here I had taken a traffic scenario as I am having 6 primary links, that is primary users. Secondary links means I am having 20 secondary users, and I am having 6 channels which are to be shared between primary and secondary. And the signal to interference ratio I have considered from 4 dB to 14 dB, and the bandwidth of the channel I have considered to be as a 20 megahertz. Again, this I worked on MATLAB. So with this, I was able to find out with the results what I have got it. The secondary links achieved higher fitness values by ABC, that is AND B colony here. Okay, just a minute. I'll just go with this thing. Yeah. So here I applied AND B colony optimization, the another optimization too. Okay, a technique. So secondary link achieved higher fitness value. Higher fitness value means least interference by AND B colony algorithm in less number of iterations and get stabilized. So this allows femtocell to achieve higher quality of service. Then again, I worked out with particle swarm optimization on different benchmarks with the scenario what I have mentioned earlier. So here ant bee colony ABC algorithm takes lesser time than particle swarm optimization to complete and provide the best fitness and location of the secondary links. So this way, all the algorithms, what you will be working out with or what I have experimented does not give best results in all the respects. So you have to find out which it will give it better in what terms. Then I have worked out again just to make you aware of one more very interesting technique again which has been explored more nowadays. There are more papers coming on this technique which is called as a teaching learning based optimizer. Teaching learning based optimization, and it is garnering more attention. And because it is also giving you the best results, what are not obtained up to now, you can also explore this TLBO technique. And this is giving improvement in better signal to interference noise ratio, specifically in our upcoming advanced networks. Again, I have taken the same sort of a scenario. So here again, this is a plot I am able to observe in MATLAB. I'm very much for the MATLAB thing and I'm able to explore it properly. So I didn't divert it yet, but now I'm going for a GNU as well. So these 6 points are indicating my primary users, and this blue dots, green dots are indicating secondary users, how they have been allotted. And this is my base station, and this total area I have taken it, the total area where the communication, the antenna is going up to that range, so that you can set it in MATLAB accordingly with different compatibility matrix. The expressions of signal to noise ratio of primary and secondary. With the data rate expression, you can give the bandwidth. Accordingly, you can find out what is the capacity of the channel. The bandwidth and SINR of between primary and secondary can be found out by putting down a proper expression in MATLAB. So with a given designated bandwidth. Then I was able to find out the results with AND B colony as well as with TLB. And with this result, I was able to find out this particular outcome. Again, here what I have done, I've compared the particle swarm optimization, which I worked with the previous paper. Then here in this, I worked out with AND B colony and teaching learning based optimization. So here I was able to get with higher data rate, the interference is also very low for this TLBO as compared to this ABC and this for the particle swarm optimization. So here I was able to get a higher fitness with TLBO in less number of iterations than that of an AND B colony. This allowed femtocell to achieve a higher quality of service, indicating minimizing the interference. And this ABC algorithm, it takes lesser time than that of a TLBO to compute. So TLPO can be best in terms of interference, but time required for TLPO will be more as compared to APC. So that way. Okay. So these were a few of my case studies. And thank you for the attention and open for questions and answers.
Yes, ma'am. Yes, ma'am.
Yes, sir.
If the participant, if you have any doubt or question, then you can directly ask to ma'am. Madam, I have one question.
Yes, sir, please.
What are the current research challenges and open issues in cognitive radio?
This is what I mentioned in my slide, sir, earlier.
Okay.
It will be most spectrum sensing, spectrum allocation, the data rate. So whatever are the challenges of 5G and 6G and how it can be addressed. So that's why I've tailored it with the case studies.
Okay.
Yes, sir.
Does it support the multimedia application and services, cognitive radio?
Yes, sir, of course, because wherever the intelligence is required, there without cognitive radio, you will not be able to work out with.
Okay, ma'am.
Yes, sir. I hope this presentation was informative.
Yes, ma'am.
Yes, sir.
Javed sir, you want to ask something?
Good afternoon, ma'am.
Yes, good afternoon.
Very great and informative sessions you have delivered.
Thank you, sir.
We really come to know all the things related to cognitive radio. I have one question regarding that.
Yes, sir.
Hello, am I
Yes,
audible,
sir.
ma'am?
Yes, sir, you are audible.
How a role does cognitive radio play in 5G and beyond 5G?
Yes, sir. I have tried to address this question in this slide. Okay, I'll
Okay.
just go to the slide.
Yes, yes.
Okay, so here, cognitive radio and how it will be helpful for the 5G and 6G. I hope the slide is visible to you, sir.
Yes, ma'am. Yes, ma'am.
Huh?
Yes,
So
yes.
these
Yes,
are the
it is
very,
visible.
yes, sir. So these are the challenges what you can really work on going towards the 6G. You can take up any of the topic in this and you can extend your work in that.
Yes, yes. And what are the industries where cognitive radio technology mostly used, ma'am?
All the telecom industries, sir. Wherever you go,
Okay.
wherever this communication is there, anywhere you can go.
Okay, okay. Thank you, madam.
Yes, yes, sir. Yeah.
Any question from participant side?
Hello, sir.
Yes, yes.
Hello. I want to ask a question to madam.
Yes, yes,
How
madam.
could we get the database for verification, ma'am? For example, if you are using channel utilization, right? So
Yeah,
how
yeah.
know the channels are replaced for testing in real time application? How do we get the database, ma'am?
In fact, when I started my work on this thing, this was the very first question I tried to address, in fact. Then I searched for some different benchmarks which were reported in the paper which I have presented right now. So you can start from that point because the work is already done. But when you want to go for a real this thing, a data set, what you're talking about, there is a test which is called as a drive test, which has been done by every service provider. It may be Airtel, Idea, Jio, and so on. So they see how many frequencies are being allotted and how many are utilized in what time. So that data they are collecting, and you can take it from them with official information. So they will
Okay,
be
from
able
the
to.
centers, from the ATAL offices or some service providers, we can collect that, right? Ma'am?
Yes, yes, you can collect from them, ma'am. So it is available.
Okay, ma'am. Thank you. Thank you so
Yes,
much.
yes, 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 yeah.
Okay, ma'am. Thank you very much. And the last it is vote of thank.
Yes, sir.
So we are deeply grateful for the enlightening session you delivered today on AI ML for communication and cognitive radio as a part of our ATAL FDP on next generation communication. Your expertise and passion for this subject matter have inspired us, and your insightful presentation had broadened our understanding of the transformative power of AI, ML, and cognitive radio in communication system. We appreciate the time and efforts you invested in preparing and delivering this informative session. Your contribution to our FDP has been invaluable, and we are thankful for your willingness to share your knowledge with us. Thank you once again for your inspiring talk and for being an integral part of our FDP. We look forward to future opportunities to collaborate together. Thank you once again for your inspiring talk and for being an integral part of our FDP. Thank you once again.
So you're not audible. Sir, you're not audible.
Hello, am I audible?
Now you're audible, sir.
Okay, ma'am. So, last it is vote of thank. So
Thank you, sir.
we are deeply grateful for enlightening this session you delivered today on AI/ML for communication and cognitive radio as a part of our ATAL FDP on next generation communication. Definitely, your expertise and passion for this subject inspires, and your insightful presentation definitely broaden our understanding of the transformative power of AI, ML, and cognitive radio in communication system. Definitely, we appreciate the time and efforts you invested in preparing and delivering this informative session. Your contribution to our FDP has been invaluable, and we are thankful for your willingness to share your knowledge with us. So, thank you once again for your inspiring talk and for being an integral part of our FDP. Thank you, ma'am.
Yeah, thank you very much, sir. And thank you all the participants. Thank you.
Yes, ma'am. Yes, ma'am.
Yes. Yeah.
Mousami, ma'am, are you there?
Yes, sir. Good evening.
Yes, ma'am. Yes, ma'am. Let me introduce first our today's resource person. Uh, very warm welcome to Dr. Mousami Munot. He is currently head of department and associate professor at the Department of Electronics and Telecommunication Engineering at Pune Institute of Computer Technology, PICT Pune. He completed his PhD from College of Engineering, Pune, completed his master's from College of Engineering, Pune, and its graduation from SVPM COE. Her professional experience includes the head of department. She worked on various posts like associate professor. She has been visiting faculty for Department of Electrical Engineering as well as for Department of Electronics Engineering at VIT Pune, PVG, and many more. Her area of interest includes artificial intelligence, machine learning, biomedical image processing, computer aided diagnostic system, and digital supply chain. She carried out the funded projects titled Smart Fruit Classification and Grading System, development of an automated system for cytogenetic analysis and classification. She also carried out the value addition project like establishing the skill and personality development program center for SC/ST student. Her work in the area of patent, some patent granted and fields like precision aerial drone for automated coconut harvesting, jaggery adulteration detection devices, then sensing system methods and devices for non-invasively detecting chronic kidney disease from exhaled breath, patent on artificial intelligence based smart antenna system for green communication. Some international patent include a convolutional neural network based methods and system for associating the face and spatial components. So she has filed a various patent internationally, UK, Australia, as well as in India, and his biodata has very diverse field of experience. So with this short introduction, I would like to welcome today's resource person, Dr. Mousami Munot. Over to you, ma'am.
Thank you, sir. Thank you for your warm welcome. It's always an honor and a pleasure to come back on this platform, to which I will always remain grateful as an alumni of this college. So thank you so much. I'm immensely honored, and it's a profound pleasure to be here. So with your permission, sir, can we get started?
Yes, ma'am, you can start.
Yeah. High regards to all the coordinators and the higher authorities of SVPM, and many congratulations for arranging such a nice ATAL FDP in a thirst area. So with that starting, and a grateful note to everyone at SVPM, many who happen to be my teachers also, and who also are the part of my alma mater. So warm regards, and let's get started. Is the screen visible, sir?
Yes, ma'am, it is
Okay.
perfectly visible.
Okay. So something little that I have been exploring and researching all about is what I'm looking forward to share today. And just, okay, presentation. Okay. So I also am gratefully, I acknowledge all the researchers and technocrats who have made their research available online and offline for students like me to study and present to the learned and very decorated participants of this forum. So the agenda for the presentation today will be, we will start with AI and ML, and we'll just see how it has been a mega stride. I just happened to look at some of the slides, and I understand that our previous respected speaker, Dr. Sharada madam, has already taken you on way on the same topic. And we'll see how AI and ML has developed explicitly for the next generation communication. On one side, when we are talking about all the research aspects that the researchers and the technocrats have been investing in, we will also see what are the downsides and challenges of AI and ML, and what are the research avenues and the future ahead explicitly for the next generation communication. So a very quick It's just like first 5 to 10 minutes. We'll walk through these slides so that the challenges and the downsides can be mapped to the introductory ones. Here, I'll just take a pause and I would like to know, are the slides and my voice clear? Are the slides visible and is my voice, am I clearly audible? I hope I am audible.
Yes, ma'am. Yes, ma'am.
Okay, thank you so much. Please feel free to stop me at any given point. And also feel free to just interact at any given point. So the first section is Introduction to Artificial Intelligence and Machine Learning. And it has now been a mega stride in our everyday day-to-day life. So maybe the first thing we start off, we check our mails, and we do see some mails in our primary emails, some of them as promotional and the others in social. So how is this tagging done? How do the emails get automatically classified in these tabs? It's AI and ML. I start using my mobile and I'm about to type something and I see the predicted words popping up. It is again AI and ML. I'm using some apps, and when I try to just categorize them, it's already ready for me on my mobile. It is nothing but AI and ML. I have watched Designated Survivor on Netflix or maybe House of Cards, and I get recommendations based on the seasons that I have watched. Again, this recommendation system, let it be for Netflix or Prime Video or Hotstar, it is again AI and ML. So I go up and have some classification and grouping systems, maybe on Amazon Prime or let it be a Flipkart, any of them. Same thing happens when I open Facebook and I have, let us say, I did try to hear to a video by BK Shivani, and I see the same recommendations that I have got, provided I watched the video for more than 2 minutes, 3 minutes of the complete duration. This happens. Why do I get the recommendations linked with BK Shivani when I have watched couple of them? Again, it is recognition system. I have my gallery full of images, thousands and thousands and 10,000s, and I want to look at one particular image and there is face recognition and matching that happens on my mobile, which again is nothing but AI and ML. So the examples go on and it can all be unending. And when I say this, that exactly is the reason why artificial intelligence and machine learning continues to be everywhere. And indeed, it is proven to be a mega stride. So, was it the case that these fields were not available earlier? Have they come out of nowhere these days? Why is it that these days they have started getting a lot of increasing popularity? The very first reason is the software is new. There are a lot of softwares that we have. If you just check any open resources around us, there are so many softwares for us to experiment. Researchers are bringing so many algorithms, so many methods, they are being published. There is a lot of hardware available to experiment on this. And the most important point, there is huge data set which is available. So data happens to be the new oil, the new fuel of this complete wheel, wherein you can imagine the data that we give on public on social media, or when I go for using Google Maps and there are some recommendations that I have asked, and this time if I take a stop somewhere, next time I choose the route, I am being asked that would you like to take a stop there, and then even in the gallery I do get photos by Google which are a decade ago. So all this data, why is data so important? Because this data tells the behavior of the human being. It tells the priorities and the choices of a human being. And such behavior and priorities will help us to develop better artificial intelligence systems. The artificial intelligence systems which are built will be closer to the natural intelligence which human being supposedly inherit. So that is the reason all these fields have suddenly popped up. So the statistics of this field was there since ages. It has always been there. But what has happened is the data, the hardware, the software, and the researchers, everything has come up which is popularizing these fields. And that's where we have data science, we have job opportunities as data analysts in data mining. All these new dimensions in the market, in business scenario, in research are all coming up. So artificial intelligence, machine learning, and deep learning, some words which are very popularly used these days. And you take any domain, these are the tools which are used. These are the tools. So any application you take, and these applications find a very good and a bright spot to make the apps better, more user friendly, more intelligent. So when we speak about AI, there is like weak AI, strong AI, and we have narrow and broad AI. So AI systems which will duplicate human behavior. We will have AI systems which will perform like human being. And we have strong AI systems which will outperform a human being. So this started back in 1950s, and then later the subset, which is machine learning, had come into picture, and its subset deep learning is now coming. So with time frame, when we say learning is one part which makes an entity intelligent, but other parts which are there in our, as in the entity of intelligence, are how is the knowledge stored? How do you duplicate that knowledge? What is the kind of language you are using? And learning is one point. So machine learning is subset of artificial intelligence. And when we speak about learning, like we human beings, we tend to learn in a lot of ways. Some of us in our younger days, in the childhood days, we must have chosen to write the difficult formula 5 times. Someone must have chosen to read it 10 times. Someone must have chosen to memorize it with some gimmick words. So when it comes to learning, there are new styles which are adopted by human beings. And then there are algorithms which depict this biological behavior of human beings sometimes, and sometimes the logical one. So deep learning happens to be one of it. So as I said, artificial intelligence is the broader umbrella where we have all these entities, and learning is one part of it. So when we speak about machine learning, it is the traditional, it is the typical style of learning. In sense, you are given an input, there are some features which are fed, and based on those features, classification is done. So exactly, if I have to give it with an example, is like how a child learns to classify a vehicle as a car. So there are some features which are fed in. A vehicle in which more than 2 to 3 people can sit. Vehicle which has like 4 wheels. A vehicle which has like dome boat shaped. And then that's called as a car. So a child looks at such vehicles and categorizes it as a car. So what was done is features of the car were fed into the kid, and those features were explicitly used in classification. So the learning was based on features, and that is what is rudimentary, or the most elementary or central idea of machine learning. Now, what happens in deep learning is I really don't worry about a lot of features. I go to an unknown place, I see something vague, and I see many such images, and then I know without any features that this is to be classified as this particular object. Like as an example, as an engineer, we learned the symbol ohm, and we never bothered to extract the features. We saw that in the subject of network theory, in subject of circuits and systems, it's used predominantly, and without bothering about the features a lot, we have learned it as ohms. Same happens to rho, same happens to sigma. So there is some learning of human being which goes and which is driven by the features, and there is some learning in the human being which is driven by the um, without the features. So deep learning is that goes without the features. I have a lot of images, and based on that images, without extracting the features, I learn. So learning is just one part of artificial intelligence. So artificial intelligence happens to be a broader part, machine learning a subset of it, and deep learning a new area of machine learning in which there are multiple layered ANN, artificial neural networks. And that's that is supposedly believed to give relatively good performance for most of the applications, but then certainly at some cost, which we will share forward. So traditional algorithmic approach, like I have a program, let us say, to add two numbers. Now, what happens in a traditional algorithmic approach is I have the data, I have the program with me, and what I need is the output. So a program to add two numbers, the program is already written. Input is asked, and what is expected is the output. On the contrary, what happens in a machine learning approaches, I have the data with me and I have the output with me, and I have to decide how can this data be mapped to the output. What program should be built so that the data will get mapped to the output? What should be the features so that the child will classify the vehicle as a car? What should be the features so that given a fruit, child will classify it as an apple? So that building that program is natural intelligence, which we are trying to just duplicate it or mimic it to an extent, outperform it in some as artificial intelligence and one approach of learning. So then, if this is so, what happens these days is every task do it by machine learning, which is not necessary. It is only the complex tasks wherein the decision making is not crisp and the features are not crisp. That's where machine learning will come in picture. For example, here if I have to give an example, is like I just want to feed in my system all graduates of year 2024 along with their class. Is it first class or second class or distinction? This I have to do for 10,000 students or 1 crore students. It's still a doable task. I will not need machine learning for it because the data set is very high. But the problem is very simple, which is driven by a rule. I might not need machine learning, but on the contrary, for the same students, I have to categorize which student is a good student and a bad student. Now here the features are not crisp. There is no logic that a student who has academically performed well necessarily is a good student. So there is a lot of vagueness in it, and there is a lot of complexities and taking into consideration the features, and such examples is where machine learning will come in picture. And the very popular algorithms which are used in machine learning, and we'll also see in the later presentation that how these algorithms are used for next generation network, like estimating the channel or the spread spectrum or the data delivery rates or the DOIs or the arrival times or the delays or the jams. We'll see how these algorithms are used, especially for the next generation communication. So supervised, unsupervised reinforcement. And these days, there is also a lot of research going on in federated learning, in explainable AI and Gen AI as well. So the broader base remains the same, wherein you have supervised, unsupervised, and reinforcement learning types. And there are a lot of algorithms under each such category. And then we will see the broader categories of supervised, unsupervised, and reinforcement deep learning in our presentation ahead. So as I did say, the new trend now beyond this is explainable AI in terms of the future prospects of AI. So what is happening till date? As of now, what was happening is you have given a lot of training data. There is the learning that happens. Your classifier has learned it. And based on that learning, classifier is taking a decision. But as the researcher, as the end user, I really do not know why did classifier classify the given input as a cat? Why not something else? Why did the classifier succeed? And why did it fail? And when these questions are not answered, I really cannot trust the system of artificial intelligence which is built. So I want the artificial intelligence system as a user as a researcher, I wanted to be transparent and fair in telling why it has arrived at the decision which it has, and was there any error. So till date, till recent past, the research was all focused on machine learning, wherein the concept of explainable AI has now come, where now what is the trend? Trend is there is new learning process, and the model of learning will explain why has it decided or classified the given input as cat. And now you see it has explained that it has fur and it has whiskers and it has claws and it has this feature. So I do understand that the classifier has taken the decision based on some obvious features. So if my classifier is taking the decision based on these features, I know that it will classify cat correctly, and I know it will also distinguish between a cat and a horse. But if I have to, with these features, distinguish or differentiate between a cat and a wolf, I know that my machine learning algorithm will fail. So the model is able to explain itself. So I understand why has it classified, why it has succeeded, why it has failed, when can I trust and when I cannot. And that is completely the new area for explainable AI, which is also gaining a lot of importance in next generation networks. So all the decisions which are made, as I did say, about the band allocation or about the spectrum or about some handling in the application layer or about the estimated times, I know why the model has arrived at it. When I have trained it on some data and I'm giving some unknown scenario in the practical deployed process. So this is the whole background of AI, wherein I just wanted everyone to be on the page and about everything of AI and ML, which will be applicable in NGC. So upsurge, especially from the from communication point of view, how there is so much of upsurge in it. What has actually happened? So there are a lot of startups in India which are now working, especially they are in all the industries, not only the tele. That is the reason there are so many tools which are readily available in market, so that these apps can be very well developed, deployed, and utilized till a layman. And these are some of the most popular tools which are being used. So the trend of even publications in XAI, especially XAI, which is the new area, that has increased a lot as we see on our slide. So given communication as the core part, AI will play inevitable role in the development of the nation. So nation, it will be definitely a contributor to the GDP, and there are a lot of initiatives which are taken by support artificial intelligence. So let it be through CDAC programs, let it be through our ministry, or let it be through some projects which are taken under DRDO or DAIT or DST, or some engineering programs, or some companies like Infosys and IBM investing especially in the AI for next generation communication. So the most important strategy which has now come is your Niti Aayog, which is AI for all. And you can see since last year, government has announced India AI mission, which in crore. So the government of India is also looking at key ways Niti Aayog, India AI mission, and especially for communication, there are a lot of national guidelines and frameworks which are formulated considering the integration of AI in communication. So one such which was done in 2018 is Telecommunication Engineering Center Initiative. It is called as TECH Initiative. And the other one is TRI, which is your Telecom Regulatory Authority of India. So there are a lot of regulation explicitly which are used for AI integration in communication. So if we look at how the national and the international perspective is, India definitely has, if we look at the global averages, India has been better than the global averages and is keeping shoulder to shoulder game with the other industries, so other countries. So leading in AI adoption at 30% and the global average is 26%. So this was the report of BCG in 2024, wherein India is marked as the leader in adapting to AI. And 79% of the Indian companies plan increased AI spending in 2025. And many of these companies also involve communication industries. So now, with this background, which I wanted to bring our respected audience on pace with, let us see where actually AI and ML will be helpful in the next generation communication and what exactly has changed, which is the mega leap that has been taken in 5G advanced and 6G, where AI will play a crucial role. So the latest advancements. Now, when we are speaking about the next generation communication, what is it actually looking at when we compare it and when we look at the evolution from 1G to 5G advanced, 5G, 5G plus, and 6Gs? We want faster speeds. We want the capacity of the networks to be high. The latency should be low, and it should be able to support new types of devices and applications. So all of us, we know now it is not IoT alone. It is not Internet of Things. It is IoT now. And we also have edge AI computing, which goes on. So every time we are looking at how much functionality can be brought in the given time, in the given device, and how can the communication be helpful, which is applicable to all the applications. I mean, let it be healthcare, let it be day-to-day communication, let it be informal communication, let it be military-based communication, communication from the base stations to the end stations, whatever kind of communication it is. So all these parts, we want it to be categorized by faster speed,
तो क्या मतलब विषय चांगला माणूस आहे सर म्हणलं व्यवहारिक आहे. त्याला कोणतं सुरू आहे मला पैसे पण एवढ्या मोडा लागतात ना.
हे बेंचमार्क्स खूप मोठे आहेत तुम्ही
Hello, ma'am.
Hello, sir.
Yes, ma'am.
Yeah.
You can continue.
Okay.
खाली आपल्याला
Sir, PPT दिसते.
आणि ह्याला म्हणलं ना बाकी कुठले करता येईल.
Okay. Sir, PPT दिसते.
Yes, ma'am. Yes, ma'am. It is visible.
Okay. Thank you, sir. Okay. I'm sorry. I got disconnected in between. I believe we were at this slide and we were talking about the applications of integrating AI in the next generation network. So, how is the trend which is explicitly for integrating AI and ML in next generation for the next generation communication? So, would like to spend a couple of seconds on this particular slide, wherein heuristic algorithms, supervised learning, unsupervised learning, deep learning, reinforced learning, all these algorithms of AI and ML are very interestingly used for various applications. And we see blue color, which is our deep learning. We see the increased use of deep learning uh, since last decade. So, speaking about evolution of these wireless networks, let it be from 3G to 4G, 5G Internet of Things, then we do see a 5G advanced. We speak about satellite communications or massive IoT or IoIT. We speak about all these parts. It is definitely looking at how much is the bandwidth that is required, what kind of internet services is needed, what are the advantages. We are speaking about the video streaming, about all the applications which can be done, especially as moving from 5G to 6G with a threshold of 5G advanced, which is also called as 5G plus, and lot of releases in the standards which is being done. And how are all this addressed by AI/ML? So on one side, we are seeing how the technological advancements have happened. And on the other side, we are seeing how the algorithms have happened. So I'll just go back to those slides and look at the AI/ML integrating in next generation. NGC is what I have used in my slide for next generation communication, and how the research papers have increased in the same domain, which in itself tell the applications that are going on. So basically, when we speak about 6G, we say that it's going to be all the gaps that we have with 5G and which are still explored in 5G plus. Okay, let it be right from broadband and Internet of Things. We have artificial intelligence, which will play a crucial role towards a fully digital and a connected world. So all these points, when we are speaking about the bandwidth especially, and the tasks and everything that we want in terms of our speed, our connectivity, our giving the bandwidths, all these parts, AI and ML will have a inevitable role at it. So if we look at 6G at a city level, or maybe 6G wireless communication network in itself, or we look at 6G just as user level, and we look at all operations of machine learning. Now, what is the predicted part is all this, let it be city level or communication or UG level, everything machine learning will have a role, and it will have it right from end-to-end communications or managing the complete energy and synergy of that particular network, checking the dependencies of the devices and clustering the devices also for balancing the load, and all the parts of other points which we consider, machine learning and AI will play a role of all of them. So if we have to focus on the next generation network, we are speaking about 5G plus and 6G to be very specific. And we do take a look at how machine learning and artificial intelligence will give us very uh, superior results, wherein let it be at infrastructural level or the application level. So when we speak about the application level, our preferred characteristics are, we want some privacy in it and it should be scalable. We are talking about AR, VR as well, augmented and virtual reality. We want clustering. We also want an internet connection which will be more reliable, steady, uninterrupted. And at the user level or the infrastructural level, uh, when we speak about it, let it be end-to-end connection, that communication that we want, or allocation of the power that we want, or validations of the data we want. We want some security in it also. We want interpretability in it as well. So the very first research area which is ongoing is how AI and ML is used at different communication level layers. So in physical layer, how it is used, how is it used is as a MAC layer, network layer, transport layer, and even at the application layer. The way researchers are looking at it, they categorize it as the infrastructural levels, middle level, and the application level. So basically, when we speak about different communication protocols, it is being categorized in these three broad levels, wherein user and application is one, infrastructural is one, and the middle level is the other one. So we do have this algorithms, like we have main CNN based parts which is being done. It is done at the physical MAC or network layer. We do have the approaches which are also done using GAN, which again is used even in increasing the databases as well. And whatever is the quality of service requirements can be our measurement of the performance parameters. So when working on AI and ML, this becomes another important point which can be done. So especially when it is for physical layer, the whole idea is how is it used for estimating, encoding and decoding the they only look at your infrastructural middle level and the application level. So allocation of the power and balancing of the load, and how is the clustering that will happen. And finally, at the end user level, which is we are calling it as the application layer, it will be used in smart cities or smart homes and all the other applications. And the part basically in this, what matters is you want the overall enhanced performance. Now that can be in terms of improved network efficiency or the security measures or better deployment as well. So one area of AI ML is always in working in these network layers and making these network layers, which happens to be the backbone of communication, more strong or more efficient. That is, and towards the end, we also look at what are the research challenges in doing it. So the presentation has been in such a way that wherein we initially will look at all the applications, we have looked at all the investments in AI, we will look at applications, and towards the end, we will look what are the research avenues, because I believe a lot of researchers must have also joined and will be a part of this respected forum. So if this presentation can give them some insights about the possible research avenues and research gaps, maybe that can help. So another next part is improving the efficiency of the network. Now, when I say about the network efficiency, it is optimization of the traffic, it is resource allocation and network cache. So all this these days it is called as AI powered or AI optimized resources, or traffic which is optimized using AI real time, or minimizing this congestion or the latency, how it is defined. Apart from these two main, we also have AI powered predictive maintenance and fault detection. Predictive maintenance in itself for next generation network is one research area wherein we are, it's like stitch in time saves nine. So you are trying to predict when the required maintenance will be, and accordingly you will be taking the action. And the second part to it is detecting the fault. So something it is like automated diagnosis, sometimes it is detection as well, sometimes it will be determine the um, overall performance of the network and think about the possibility of maintenance. And whenever there is some fault, it needs to be isolated without disrupting the other network parameters and addressed immediately. So predictive maintenance and fault diagnosis. And one very popular area which everybody is like looking into is how do you improve or enhance the spectrum utilization with AI? So when we speak about AI, there are algorithms to predict it. There are algorithms to allocate the spectrum very intelligently and wisely. Algorithms to take a look of prior knowledge and use it in its execution. So most important area is dynamic needs. How are they do? So there is a concept of this incremental learning in the machine learning algorithms, wherein the threshold based on which the decisions are taken in itself is kept dynamic. It changes with time. And when it changes with time, many a times the performance is better. So dynamic spectrum allocation or sharing the spectrum. How long did we have the actor users? What has been the history? Keeping the record of it. Likelihood of activation of the users. A necessity of the term lines. How do I allocate the given bandwidth to the users, predicting their time of activation? All this demands artificial intelligence, which can be done. One very important part is managing the network and self healing. So basically, in this particular task, AI will automate all the network tasks, and human intervention is almost zero. Now, on one side, when we say that the human interference or intervention should be zero, what research has told is the best systems are hybrid systems in which AI and a human being are working together. That happens to be the most outperformed systems is what has been told. So self-healing, another research area which is very commonly used, especially for NGC, is wherein automatically or continuously network will monitor its performance and adapt to changing traffic patterns and ensuring it. Like, and we do experience it. Like when I have Google Map, every time it will tell me that this much time is there, but then it will again ask me 2 minutes faster, 2 minutes slower. Do you want to change its route? Do you want to stop here? So whatever satellite imaging does show, automatically the given plan works on its own net traffic management to make better choices or to propose better choices to the users. So that is another dimension wherein next generation networks are expected to be dominating, as we did see in our early slides, and that is where artificial intelligence can be uh, used. And then another important part, which is network security and anomaly detection. So preventing the intruders, detecting it, if there are some threats, if there are possible attacks, if there are some changes, automatic shutdown of the network with prior alarm, and ensuring that the layers are secured. So all these parts are main entities for the next generation networks wherein AI will play a role. And if we speak about AI or machine learning, which are the possible algorithms? Which algorithms of AI and ML have been tested as of now? And what results are being given? So a quick look even at those. So supervised learning, wherein we see that there is some raw data and you have a supervisor, and this raw data comes with a label. We know what is the class of the raw data. So we have an algorithm and there is the processing that is done and you get the output. So there are a lot of, as we will see on the next slide, There are a lot of popular applications of supervised learning in NGC. Some of them are listed on the slide, and there are research papers available for each of them, for tracking the targets, for collecting the data. Please remember, collecting the data is something which is very important to improve the performance of the build system. You initiate a call on WhatsApp, it immediately will ask us, come on, rate this call. Will you give 5 on 5 star? If we give 2, it will immediately ask, what went wrong? Was it the audio that went wrong? Was there some interference? Was there some continuous cutoff? What went wrong? Now, why is WhatsApp bothered to take this feedback? Because based on this feedback, the features can be improved. So collecting the data, that is one very important part. Video encoding, having energy efficient sensor clock synchronization. So whenever we are speaking about efficiency, energy efficient networks, ML algorithms are done. Blind spectrum sensing. This again is a very hot area of research. Protection against the DOS attacks and indoor localization. So there are a lot of such supervised learning algorithms which are experimented on this, and it has reported to give some very good advantages also, and there are some disadvantages also. So most important advantages, when you have the real-time data with the groundwork, real-world computational problems like predicting the target values, this is something which is reliably solvable. So their supervised learning algorithms have been used in the next generation communication, and regression comes in picture of prediction. So whenever I'm trying to predict something, that's where I'll have binary or logical regression, linear, I can have non-linear, depends on the pattern of the input. But what basically is the limitation? When I go for very large data sets, the accuracy is reported to reduce. And another part is clustering and classification of data sets was not very well encouraged, did not give encouraging results. So on one side, when we are saying both the sides I'm trying to present, wherein what do the research papers say as its advantage and disadvantages? So similarly, when we go, as we say, there is no supervisor, in sense, there is no ground truth with you, and you are to take the clustering approaches to find the class. So that is where your unsupervised learning comes in picture. So it is without any teacher or without any supervisor, in sense it is without any ground truth. So such unsupervised learning algorithm, they find very good application in device clustering and in edge computing. So whatever is the delay of arrival, again predicting those costs, or channel multipath clustering, or allocating it. Basically, when it comes to clustering unsupervised algorithms, there are a lot of unsupervised algorithms. You do have KNN as one of the most popular unsupervised algorithm, and it is up to the research to find the value of K in those cases. So when the data is less complex, and as the very first advantage is written, it does not require the labeling of data. Labeling of data is nothing but the ground truth. In all such cases, unsupervised learning is very well used. And what is the problem with it? Computationally, they are little complex, the unsupervised learning algorithms. And that's where the research has also gone ahead to reinforcement learning and the federated learning, and even deep learning. So reinforcement learning is learning which is based on reward and punishment kind of the thing. So if the agent, the central idea of artificial agent in artificial intelligence is building a rational agent. There are 4 dimensions of artificial intelligence, and why reinforcement learning agent has come in picture, we will just spend some time so that we can map it to the NGC as well. When building the systems, even as a human being or as a researcher, I am not clear what I really want. my needs change with the application. I do not want the artificially intelligent system to always think humanly. I do not want it to always act humanly. I do not want it to always think rationally. I do not want it to always act rationally. So 4 dimensions which are given is thinking humanly, acting humanly, thinking rationally, and acting rationally. But as a researcher, all these 4 dimensions are applicable in varying situations. To give you an example, if we define our requirement as thinking humanly and acting humanly, there are many incidences when human beings behave irrationally, unacceptably. Human beings, in some unfortunate cases, human beings committing suicide. This is not something which we want our AI system to build. So the definition of acting humanly and thinking humanly is not something which will always be applicable. So the central idea of artificial intelligence is be rational in your behavior. And that's where the concept of rational agent has come in picture. And that is where reinforcement learning has an agent-driven system which works on reward and as good as on punishment. So if you are achieving your goal, there is some reward given. If you do not, there is some punishment. Punishment is nothing but a feedback that goes on. So reinforcement, positive reinforcement is what all human beings need. And that is exactly what is done in reinforcement learning, and which again has similar applications in NGC. Same is the case with deep learning that we just discussed on the slide, that what happens in deep learning and why there is a necessity of large data sets when it goes to deep learning, because we are not going to learn based on features. We are going to learn based on all the images that we have. That's where we have deep learning. And the new area is now federated learning, in which you have a group of devices which are learning together. So what is done is, in the neural network, I'm taking the summation of all the weights. You do see there summation n of k by n weights. So for one, let's say that computer, there is this weight of omega 1. You have another devices omega 2. You have still another devices. And you are learning as a group together, which is your federated learning. So all these learning algorithms, they have given encouraging results for various tasks which were listed in next generation communication, but it did come with some advantages and some disadvantages. So as of now, there is no algorithm which has only advantages. All the advantages we get will be at the cost of some other disadvantages, and it is for us to decide that what exactly do we want to go for. Now, so one area that we saw was use of AI in various layers, right from physical layer, I mean infrastructural, or till user application. Then we saw other dimensions of next generation network, wherein it was used for network efficiency, or it was used for intrusion, it was used for security. And then one more very hot area of research is use of AI in communication protocols. So as we know that there are protocols which are being devised, and these protocols usually now, whatever is research is going on, it is for 5G and even for 6G. So AI is playing a role in it as well. So AI, as in 5G, you have AI even in network slicing protocols, wherein you are deciding to create, manage, and optimize the slices of the network. That is one very important part. We know IPv6, it's again being versionized. Again, AI is helping in the optimization to analyze the traffic patterns. Even in MEC protocols, AI has a role, and similarly in others as well. So including UDP, all these parts AI has a big role to play in. And I will just take a pause here, and can I request some additional 15 to 20 minutes, sir?
Yes, ma'am. Yes, ma'am. Sure.
Thank you so much, sir. Thank you so much. So, the whole future of artificial intelligence in next generation communication systems, first definitely it is about 6G, and research is also going on 5G plus, which is called as 5G advanced. You do have it in edge computing, because you're going to have lot of devices to devices connectivity. We say D to D, lot of devices, there will be connectivity in it, and this connectivity needs to be on an intelligent basis, which will enhance very good performance. Slicing, that means nothing but we are customizing dynamically based on the dynamic needs of the environment and the other parts as well. So this was almost half of the presentation, wherein I just wanted to list out all the areas where artificial intelligence is being used, and every point that is listed towards the end, I'll also share some very good research papers, which will give you the next future direction also. But when we are talking about AI and ML in specific, are there some downsides and challenges as well? We have been talking about everything good which AI can do, but what are the challenges and the downsides of the same? So, very important regulation had come up in 2018, which is called as GDPR, General Data Protection Regulation. Now, please understand, we have Alexa at our home, and Alexa listens to everything. So everything that we are discussing in private, mind well, it's being recorded. So I I mean, I want a system wherein I need to be careful that if there is some very private discussion and talk going on, Alexa needs to be switched off. And again, is it really not listening when it is switched off? So whatever is your data, how are you going to protect it? And that is where your right of protection and right of explanation has come. And every point of AI and ML, there will be two questions which will come. How fair is AI and how trustworthy is AI? So that is the biggest challenge and downside, especially when we are talking about AI for two applications. The first one is in biomedical field and the second one is in communication. There are other applications wherein um, privacy or trustworthiness might not matter to me a lot, and a fair idea helps me. But medical applications and communication, especially you can imagine about military operations driven by such D2D communication, we want it to be very private and very fair without any bias. So most important part, downside of AI, and please understand, this is explicitly only of AI and ML I'm talking. And next part of the presentation will talk about the downsides of AI and ML for communication. These are overall, and some of them are applicable to communication as well. The next one that you see on the slide is how, what is the bias? Like long back on Google, if I will type bride, only US or your Western brides will be seen. Indian bride was not seen on Google at all. The reason was, lot of researchers in US, they will upload the images which are based to their nationality. And when we are speaking about global scenario, it is necessary that everything has to be, all ends have to be considered. So then is artificial intelligence exhibiting some bias towards what it has, is what it will show. And this is not something which will be expected. So there was a very good paper which received a lot of appreciation and cites that is AI sexist and is it racist, and it's time to make it fair. And that's where fair AI is something which has still been rolling down the grooves of all the researchers. Same happened back, and it is still not solved, wherein Google mistakenly tags black people as gorillas. The model is trained for gorillas, and Google had to pay a huge fine because of it. And when we are speaking about all this application, which since when? I mean, almost a decade, and still it is being stalled. And even today, the problem is your AI fair? You look at a very simple example wherein how does AI differentiate between a dog and a muffin? And you see so many images here. And is it really easy if I decide that there are only some brown, I need to look at some brown triangular positioned spots which indicate two eyes and a nose, and it has to be compared with a muffin which has, let us say, chocolate skins in it. So there's so much of confusion, and it is still difficult for AI to differentiate between a dog and a muffin. And you can imagine the same is the case with a dog and a mop. The features which are given are more likely like a features of a mop, leaving AI to making it very challenging for AI to do such simple tasks also. Excuse me. Same part again when we speak about a red shoe and look at the feature map that has been developed, and same image wherein a kid is using a binocular and still giving the same fluff. So all these parts are very difficult for AI. So on one end, we are talking about robotic surgeries. We are talking about all the incidences and existences which will be done by AI. And on the other side, a simple problem like differentiating between muffin and a dog, or a mop and a dog, or a quandy and a squirrel is also very difficult for AI. So this feature-driven learning and the quality of catastrophic forgetting which AI has is something which is a hurdle in its growth. We human beings, I mean, even if like we learned digits in first standard, let's say 1, 2, 3, 4, 5, what is important, we carried it from first standard to second standard, and from second to third, and from third to fourth until date. Now we have conveniently forgotten some nursery rhymes which are not used today, but we have very well noted something which will be used even right now and for days further. Now this feature of plasticity and elasticity which human being has, that AI, bringing that in AI is very difficult. So that is the major challenge and the downside of AI. And the another part is how do you select the best AI model? Like on the other some slides earlier, I did show that supervised learning can be used, unsupervised can be used, reinforcement learning can be used, FL can be used, federated learning, deep learning. Which of them is really good? With change in data set, the performance of the algorithms will change. And how exactly should I decide that which algorithm is good? Just to give you an example, this is just as a fun game, we have some kinds of these quizzes coming up on WhatsApp or even on Facebook, wherein I am given 2, 2 should be equal to 5, 3, 4 should be equal to 14, 4 and 6 as the input, and I should get output as 27, 5 and 8 as input, and what should the output be? And then I start thinking and I develop a model like A star B plus B by 2 will give me the result. So I decide that 5 star 8 is 40 plus 8 by 2 is 4. So the answer will be 44. And I realize that I will also get the same answer if I do A star B plus A minus 1. Example, I do 4 star 6, 24 plus A minus 1, which is 4 minus 1, 3. 24 plus 3, 27. So on the data which is available, model 1 is A star B plus B by 2. Model 2 is A star B plus A minus 1. And which amongst these two models is good? Which one should I be using? And as long as both the models are giving you correct result, it is okay. But what if there is an unknown sample 2 and 1 and both the models will give me different results? So if it is 2 and 1, the result that I get with model 1 will be 2 ones are 2 plus half, 2.5. And the answer that I get with model 2 is 2 ones are 2 plus 0, that's 2. So there is a discrepancy, and which model is good. So there is a lot of research going on finding one good model, and it's very difficult to arrive at it because the performance of the algorithms will change with the data set. And then there is a typical problem in history wherein husk and wolf had to be differentiated. And what artificial intelligence was doing is, instead of using the features of husk and wolf, it was actually making decisions on presence of ice. So that is where the whole challenge of AI comes in. How has the decision been taken? Can that be explained well? Another very popular case in the history of compass, wherein what was happening is, it was a decision support tool which was developed in US courts, and it was just to develop to understand the likelihood that how that defendant will he again turn to a lawbreaker, and more oftenly blacks were wrongly identified. So now this was again, there was discrimination in the gender. So there is so much of research going on that are this network prejudiced? Will they really behave like human beings? Is it specific features are there? And what actually are the explanations given? What is the this part? And what are the current challenges that go on for AI? What AI cannot do? And this is a very nice paper which is available on Springer. What are the challenges of artificial intelligence? What are the challenges of integrating AI to any of it? And they have taken a lot of examples. So if I have to summarize all of this, there are some of the ethical challenges, bias, misuse, privacy. Then there are challenges like technological challenges. How do I decide its explainability? Hallucinations, where do I see wrong results looking like the correct ones? What about policies and regulations? There is a self-driving car on the road and it leads to some destruction. Now, if it leads to destruction, who is going to be who is going to be responsible for that destruction? So there are a lot of judicial and legal paths, and that's where Elon Musk and others, they have just told, take a pause. And recently, just last week, you must have seen this news hitting the market, wherein Apple pulls error-prone AI-generated news summaries in its beta iPhone software. So Apple had to take it back because it did not work well as trusted. So they had to suspend that feature. So all these challenges are still there when we are speaking about all the applications of AI and ML on one side. So one side, we do say that there are so many applications, but then there are these challenges as well. And now when we speak about next generation network, the very first is private data privacy, bias and fairness. What about job displacement and even the security threats? So there can be some decisions which are needed to be made autonomously. Will AI be able to do it with fairness and without disturbing the privacy? And will that decision be trustworthy? Will AI work in human collaborations? And will it really be to a scale where it can be done? In next generation networks, scalability is very important point. We are speaking about D2D and IoT. So how the scalability will be and real-time processing, is it really possible with AI? What will be the quality and availability of the data? So we want the system to take decisions in whatever case we want, we pose. And does AI have so much of diverse data to learn from? So to give you an example as a teacher, if I want my students, let's say I'm teaching a primary class, and I want my students to do well in addition sums as well as subtraction sums. it is very important for me to take examples on addition as well as take examples of subtraction in my class. Now, what is important? AI will take some decisions in favor, some decisions against. Does it have enough sample to take decisions against? It will have a lot of cases to take decisions in favor. Example, AI for HR, HR department. There are a lot of examples in an organization of promotion, given increment, but there is rarely an example of termination. So if we
Hello. Hello, ma'am.
hello, sir.
Hello.
Hello.
Hello, ma'am. Yes, ma'am. Yes, ma'am. You are audible.
Yes, sir. I'm really sorry. I just got disconnected.
Yes, yes, yes.
Okay. Is the slide clear? Section 7, research avenues.
Yes, yes, ma'am.
Okay. So what basically are the research avenues? What will be the future? The first very prominent area is AI-driven network design. Designing the networks which are driven by AI. Edge and federated learning, we did speak about it. Even ma'am spoke about green communication. We spoke about AI in various layers. And that's where you can have augmented physical layer. What are the security enhanced features? We spoke about explainable AI explicitly for satellite communication. So what gaps with these avenues, what are the gaps which can be done by the researchers? So the very first is standardized data sets and benchmarks. As of now, what is the gap in the literature? There are no standardized basis of AI and ML. And there is no benchmarking wherein it can give the researchers a way to ensure that the results are not merely indicative, but can be thoroughly compared. What are the energy efficient techniques? Cross-layer AI design for your physical Mac and application layer. That is one very important research area. And if you go, you'll see that all this, there is research that is happening, but they are still, um, it has received mega attention or dynamic and adaptive AI models. So preserving the privacy, the hardware constraints that come, or even AI enhanced spectrum sensing. Current AI models, they're not optimized for highly dynamic uh, environments, and that is one area wherein researchers can do. Or spectrum sharing systems that are there, they're not completely driven by AI. So there is lot of way ahead when we speak about AI, and especially when communication, next generation communication system will hit every dimension, every application, and that's where 2025 Elon Musk again has another resolution. So the most important part is, will AI be replacing all the human beings? And the point is, AI will not replace human beings. People using AI will definitely replace the ones who cannot use AI. So always, when we look at a curious peep and we are talking about all these parts, somewhere people feel that there is no idea that where AI will take the world. And somewhere, as we did say, my neural network is still struggling with dog and cat, and muffin and a dog, and a mop and a dog. So there are some ground level uh, downsides as well. But with all this, the opportunities and the challenges, they keep on outweighing each other, and that's how the wheel of the research keeps on going on. So that is very important, and this definitely is something which can be taken by enthusiastic researchers. So there are opportunities and there are challenges, but AI will drive the future. So excuse me. With this note, thank you so much for your patient listening.
Thank you, ma'am.
Yes,
Now
sir.
it's the time for question and answers. Participant can ask question to ma'am.
I really hope it has given some insights to all the learned and very knowledgeable participants, and their investment
Yes,
of
ma'am. Yes, ma'am.
90 minutes has been helpful for them. That is all we look at.
Yes, yes, yes. Madam, in deep fake images or videos,
Yes,
can
sir.
AI, what is the role of AI/ML to detect the deepfake images as well as videos?
There is work going on, sir, in looking at the originality of the images. Are they fake, or are they fabricated images? So there are some invariant features which are used in such algorithms which decide based on it, and there is some confidence level which is given about its reality or fakeness, sir.
Yes, ma'am. Yes, ma'am. Participant,
You
if
can
you have
also
any question, then you can ask to ma'am.
reach out to me for any point where any interaction you wish to have, even later. And if you need all the research papers that I have referred, please reach out to me. I can post it or even share it with our respected coordinators.
The last but not least is the vote of thank. So, dear ma'am, we are deeply grateful for enlightening the session you delivered today on AI/ML for empowering next generation communication as a part of our ATAL FDP on next generation communication. Your expertise and passion for this subject matter have inspired us, and our insightful presentation has broadened our understanding of the transformative power of AI/ML in empowering the next generation communication system. We appreciate the time and efforts you invested in preparing and delivering this informative session. Definitely, your contribution to our FDP has been invaluable, and we are thankful for your willingness to share your knowledge with us. Thank you once again for your inspiring talk and for being an integral part of our FDP. We look forward to future opportunities to learn from you. With this, once again, thank you, ma'am.
Thank you so much, sir. Very grateful to you for this opportunity and to have such a nice participant crowd there, sir. We wish you all the best, and we again, once again, congratulate you, sir. I'll take your leave.
Yes,
Wishing everyone
thank
all
you, ma'am. Thank you.
Thank you, sir. Thank you.
Okay, ma'am. Pravin, are you there? Pravin, sir? Pravin? Okay. Let me introduce today's resource person. So our session it is by Mr. Pravin Langade. His current designation is Engineering Manager, Product Manager, Battery Management System at Lear Corporation, Pune, Maharashtra. Pravin has 17 years of industrial experience in instrumentation and automotive domain. He has 12 years of experience in Lear Corporation, collaborating with clients such as Ford, GM, BMW, Volvo, Grelli, M&M, and worked for Tata Motors before joining the Lear Corporation. In managing lights and electrification, he worked on SW product line at regional level, where the Volvo SCM Gen 2 project achieved the automotive spice with 3.0 capability with level 3. He led the Mahindra and Mahindra mainly in the seat control module project from RFQ till the successful launching. He also has experience in achieving IATF certification for E-Systems ISC Center. He is an active member for establishing the SAFE project was a pilot initiative. He is a certified ASPICE V 4.0 professional assessor certified. So with this, I would like to welcome today's resource person, Mr. Pravin Langade. Over to you, Pravin. You are co-host now, so you have to unmute yourself. Hello. Pravin, you have to unmute yourself. You are co-host.
Hello, can you hear me now? Hello.
Yes, Pravin,
Okay, good.
you're audible now.
Okay, should I start my video or it's not needed?
Yes, you can start.
Okay, good.
Yes, your video is also visible now.
Okay, good. Okay, so first of all, thanks for inviting me, okay, in this ATAL FDP program. I am, the ex-student of College of Engineering Malegaon, okay, from 2007 batch. And it's good to see you, okay, professors again in the session. So I heard that this is the last lecture, right? The last session from the FDP. Okay, good. So yeah, you might be tired, all the teachers, because usually you give us lectures and no, we get tired. But now I think this is your turn now, right? So I will try to make session as much interactive as possible. Okay, and here the topic is about the communication in the battery application. Okay, so I think you heard a lot of topics, I guess, in terms of I see now AI, some communication between different domains. So now, in my case, I will be talking about communication protocols for the battery application vehicle to grid communication. Can you see my screen, by the way?
Yes, it is clearly visible.
Clearly visible. Okay, now I am switching to the PowerPoint mode. So is it also visible clearly?
Yes.
Okay, good. So yeah, thanks for inviting me again on this session. And as you know, sir already introduced, like I am working as a product manager. Basically, now I'm working in the Lear Corporation, and recently, in couple of years, I am working for the battery management system. Okay, which is BMS we call. So I am bit familiar about how electric vehicle works, as well as what is the role of battery management. Also, what are the communication between different ECUs inside the vehicle. So today I will touch upon all this. But before starting, okay, does anyone want to say anything? What they know about the communication with in battery application or vehicle to grid? Hello. Hello, can you hear me?
Yes. You may go on.
Maybe I will stop video if you cannot hear me properly. Hello, sir. Can you hear me?
Yes. Clearly audible.
Okay, clearly audible. Good. So what I want to start with, is there anyone want to share their thoughts or views on the battery application or communication? Is there anything you guys know? So can anyone want to say something before we start? All are tired, right? Listening and listening. Are we alive today?
Yes, Pravin.
Okay. So I think you need to unmute, right? Others, they cannot talk directly, right? This is what I understand.
No, right, okay. I allow permission to unmute themselves.
Okay then. Okay, then feel free to interrupt me, okay, if you have any questions, because I am not a lecturer. I am an industry person from last 17 years, so I might not have that much skills, okay, to present the way professors do. But yeah, I will try my best, okay, to at least explain what is the concept here, and yeah, try to give you the insights. Okay, so going ahead, uh, what I will cover today is like vehicle architectures in electric vehicle, as well as the communication protocols in EV, and what is vehicle to grid. Hello.
Yes, yes, yes.
Okay, I am hearing someone is talking. So is there any question?
No, no, no.
No. Okay. Okay. Then yeah, this will be the today's agenda. I will explain you a little bit about the vehicle architecture in short, and then we will switch to the communication protocols in EV and the vehicle to grid. Okay, what is vehicle to grid, and yeah, what is the technology, what are the challenges in it. Okay. So moving ahead, I will explain a little bit about the vehicle. Okay, you all might have now the four-wheeler, right, with you, maybe with any brand, Maruti, right, Volkswagen, Skoda, right? It depends, but yeah. So what I will try to share here is, if you see this picture, in a car, okay, there are different controllers. We call it as a electronic control modules, okay, ECU. So if we
Praveen,
go, yes,
sorry to interrupt you. Your slides are not moving.
not moving.
Yes, yes, yes. We are observing the first slide.
Okay. I am here in the
Yes,
slide.
yes, yes, yes.
Now let's first check whether now it's moving or not.
You are on the third slide.
Yeah, I'm on the third slide, but I am trying to see, okay, if I can move. But what I am moving the slides, okay, just to
You
see
just
with
resume. You just click on resume the slideshow.
resume slideshow.
Yes, yes. In the
Resume
slideshow,
slideshow. Yes.
yes, yes, yes.
And then if I click, can you show the see the fourth slide now?
Just a minute now.
It's still third. Maybe
Now we are not. Yes, now. Yes, 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 yes. Okay, screen is visible. You just click. Yes, click on that.
yes, I am clicking there. Now you see the third slide, correct?
Yes, yes, yes.
Okay. And if I go to now fourth, can you see the fourth one now?
No, no.
No, then there is some problem.
You can just check your share option. You can share the entire screen also. Another option.
Okay, I will do that.
You first of all stop sharing, and then once again you share it. Yes, yes,
Okay.
yes. Now you just click on share and share your entire screen, and just check. Yes, yes, yes. Now it is visible. Now just check. Yes, yes. Now it is in moving mode.
Okay, good. Thank you. Sorry for this interruption. Maybe I only shared the PowerPoint presentation previously. Okay. So now let's start again. So you already have, no? Most of you already have the four-wheelers, right, inside or with you. And if you see, okay, there are, some control modules inside the vehicle. Okay. I am trying to explain it a little bit here. Okay. So it has a body control module, okay, which is a ECU, which take cares about wipers, windows, locks, lighting systems. Okay, so all these systems are controlled by this body control module. There is another controller called as airbag, so it controls airbag opening and at the time of accident. There are certain controllers like heating, ventilation, air conditioning, which takes care of cooling the vehicle. Also, there are some heating elements there. Anti-theft is for it's giving alarm, okay, when vehicle is getting theft. Another is engine control module, which cares about the all engine parameters. Okay. ABS, anti-lock braking system, stability. So these are taking care about how the vehicles, when you are driving the vehicle, they're taking care of the stability, okay, of the vehicle. Then keyless entry, so which if you have a car, okay, if you keep the key in the pocket, and if you go near to the car, then if you press the unlock on the handle, the car gets automatically unlocked. Then there is tire pressure monitor system, which always monitors the tire pressure and sends the pressure, temperature of the tire to the control modules. Then the telematics issue, we will see detail what is the use of this, but yeah, telematics issue mainly used, okay, to communicate the vehicle with other infrastructure like maybe internet or all, okay. So you have this kind of plenty of electronic control modules inside the car, and they are communicating with each other inside the car, or they are communicating outside world, okay. And that's the reason communication in an electric vehicle or any vehicle is an important aspect, okay. So in spite, okay, we should have a, when we buy a car, we see, okay, we look for the engine first, then how it looks like, how many seats are there, how many airbags are there, how what is the mileage and all this stuff. But also it's important to know how they are communicating inside, which within the vehicle as well as to the infrastructure. So these controllers, okay, what I'm showing on the screen, they are a kind of controllers in electric vehicle as well as non-electric vehicles, but they are more or less similar, okay, control modules which are controlling all automatic features, okay, we buy, and the communication between the different modules. Then if we go to the electric vehicle, okay, so what is the difference now in electric vehicle? Electric vehicle does not have the internal combustion engine, so they do not have the engine. But what they have then, they have the battery pack, okay. If you see this is a big battery pack they are having. Basically they are also having a charging port where you can able to charge the battery, okay. And they have certain controllers like onboard charger, thermal cooling, power controllers, that we will explain in detail later. But yeah, these electric vehicle are having mainly the controllers also for the controlling battery health, as well as converting DC to AC, AC to DC, and all this, okay. So these are the additional things, okay, which electric vehicle has from the conventional vehicles. It also has a 12-volt battery, okay. So if you know, in our conventional vehicle, non-electric vehicle, there is a 12-volt battery, right? And this is responsible for keeping on the wipers, lights, and also most of the loads, okay, in the electric or non-electric vehicles are driven by 12-volt battery. So these are the extra components, okay, in the electric vehicle. Can you see my next slide?
Yes, yes, yes.
Okay. Now, there are a couple of types of electric vehicles. One is a hybrid electric vehicle and another is pure electric vehicle. Can anyone tell me the difference between those? Does anyone knows what is hybrid and what is a pure electric?
Hybrid means the combination of fuel.
Yeah, okay, good. Yes. That is a major difference, correct?
Yes, yes, yes. Both the technology that particular vehicle is working or taking the fuel of petrol, as well as second, that vehicle is also chargeable.
Yeah, sometimes not, sometimes yes, because
Yes, yes,
in hybrid also there are two types basically. One is hybrid, pure hybrid, and another is a PHEV, plug-in hybrid. So plug-in
okay.
hybrid vehicle is having the charging port.
Yes,
So
yes, yes.
if you see now in the current Indian market, okay, you have some Honda cars or like these are the hybrid vehicles, okay, which doesn't need any charger, okay. So
Okay.
there are certain vehicles now which are already in Indian market, which are together with the internal combustion engine plus 48-volt battery, okay. So we will see means in such vehicle, okay. Usually we start it with internal combustion engine. It runs on engine, but whenever it takes a certain speed, then they try to switch to the battery. So there are certain algorithms developed, which make sure that switching between the IC engine and the battery. The battery is not higher power battery; it's a lower power battery. So, for example, if we get a mileage of 20 kilometers per liter in normal vehicle, in hybrid vehicle with the lower battery, we will get 25, 20, 30 like this, not pure electric like. Okay. So what they do, they try to switch to the battery in some times. Okay. So there are certain algorithms, okay, which decides when to switch to the battery and when to switch to IC engine. And this is now in already in Indian market, but I am talking now here about also a plug-in hybrid. So plug-in hybrid vehicles, they are having the higher battery, higher voltage batteries like 400 volt, 800 volt, okay, and they have the capability to charge them also. So together with internal combustion engine, they are also having the higher rated batteries, okay. So these are a couple of types of hybrid vehicles. So what happens in hybrid vehicle, okay? Let's see, here is the charging port of the vehicle. So communication starts from here. So we will have either 120 or 240 volt AC. So in the vehicle, there will be a ECU or a electronic control module, which we call as an onboard charger. Okay, that onboard charger will convert AC to DC. So because at the end the battery packs or the battery in the vehicle is DC, so they will convert it to DC, and then we will have a energy store system, which we call it as a HV battery pack. So here we will have the battery pack which will store that DC. Okay, and this battery pack will come together with controller. We call it as a battery management system, or so the battery controller. Okay, so the battery pack contains the cells which will store the energy as well as the controller. That controller will monitor the temperature, current, voltage of the each cells. Okay, and then it will also try to balance the charge of the cells. So there will, based on the different variants in the vehicle, they might have 105 cells, 132 cells, so it depends. So this controller will make sure to monitor voltage, current, temperature of each cell, also monitor the charge, and it will try to balance. Okay, if certain cells are getting discharged frequently, so what the controller will do, they will take charge from another cells and try to balance this in the vehicle. And then here a junction box. So this DC will be passed on to the high voltage. This is a junction box again. You just the junction box is used to having the some certain fuses, and it is used to pass on this DC internally, okay, inside the vehicle. So what it will do, the junction box, the junction box will have another a DC to DC converter. Okay, so now here we have the high voltage battery packs. Let's say it's a 400 volt battery, and there are certain loads, okay, inside the vehicle which need 48 volt. Okay, so like air conditioning, chassis, electric chassis, as well as electric steering, heaters. Okay, heated windscreen. So these are some loads, okay, inside the vehicle that might need the 48 volt. So that 48 volt is generated out of this 400 volt, for example, and through the with the help of DC to DC converter. Okay, then this will be passed, this DC, again by DC to DC converter, and they will make 12 volt from that. So 12 volt, 12 volt is required for certain switches, right? Body controllers, so certain systems. Okay, so from this higher voltage battery, we will have 48 volt for certain loads. We will have 12 volt for certain loads. So if we want to turn on the wipers, lighting and all, these will come under 12 volt. Okay. Then this DC will be also passed to some electric water pump, because in electric vehicle cooling is very important. Okay, because whenever we drive the electric hybrid vehicle also, and the battery temperature gets increased, so it is important to have the cooling. So there are certain cooling pumps, some certain heaters. Then this DC will be passed to AC compressor, and also this DC is passed to the inverter. So the inverter job is to make out of this DC, and it will pass the AC for motor. So at the end, motor is the one which will drive the electric vehicle. Just a moment. Sorry. So out of this DC, this inverter will convert again it to AC, so that it will be provided to AC motor, and that will drive the wheels. Okay. And here in hybrid vehicle we also have the internal combustion engine, and then it will again have the generator. So at the end, the wheels will be driven either through internal combustion engine or through directly to the DC. So as said, hybrid vehicle is a combination of driving it. It will be driven in a combination of internal combustion engine as well as the DC battery. So this is, a kind of higher level architecture, okay, inside the hybrid vehicle. Any questions on this?
No.
No, more or less getting flavor
Yes,
of what is hybrid.
getting properly.
Okay. And as I said, I am not that much having experience in the teaching field. Okay, so I will try my best to explain and try to visualize it. Okay, as much as possible. So yeah, so this is a hybrid vehicle, and if we go to the next slide, this talks about the electric vehicle. Okay, so it's a pure electric vehicle again. So the pure electric vehicle will have the complete battery pack with some battery controllers. Okay, so you will get the charging. We need to charge, okay, this vehicle. So there are certain chargers. We will see what types of chargers also, because again this is a combination between vehicle and charging station. So this battery charger will charge the battery, and there will be a controller like hybrid. So this controller will be like battery management system, and then this will be the battery power will be again converted from DC to AC, and it will be given to the AC motor. So here there will be no role of the combustion engine. So directly battery power will be given to the AC motor through DC to AC power inverter. So there will be mechanical coupling, and that will be connected to the wheels. So the only difference here from hybrid to electric vehicle, there is no combustion engine, and all the functions will be driven through the battery. So let's go back. So what I am doing, okay, as a current role in my company, as I said, I am a product manager for the battery management systems, which is a battery controller. Okay, so I am responsible for developing the battery management system for different customers. Okay, so which monitors the state of health of battery, like state of charge, state of health, voltage, current, also does the balancing. Okay, this is my role. Okay, and also as a company we are developing onboard chargers. Okay, also DC to DC converters. So in electric vehicle, also this high junction box. Okay, so in an electric vehicle, in spite of developing, or only we are not developing the electric motor and the battery pack. So we are not developing battery pack. So the battery packs are getting developed by another supplier, but in that battery pack we are fitting our controllers. And as I said, we are also developing onboard charger, DC to DC converters. So these are the high voltage junction boxes. Okay, so in real electric car, okay, what happens? The HV battery pack, then through high voltage junction box, through inverter they are connected to the electric motor. Okay, And in any electric vehicle, the safety is top most important. Okay, because internal combustion engine vehicles are running in on road from certain years, so they are having stabilized system. But in electric vehicle, when the safety aspect is more important, because if by chance if any accident or anything happens, okay, then we should immediately disconnect this battery pack from the motor. So all the disconnection should happen within fraction, okay, nanoseconds. So otherwise, if battery is still there, there are a lot of chances that burning will happen. So our controller is responsible for complete safety of the vehicle in terms of battery pack. Okay. So we are continuously monitoring the inputs from battery pack, junction boxes and all. Okay. And we are trying, okay, whenever any abnormality happens, we are opening the contactors. Contactors means these are all contacts. Okay. We are opening. We are responsible from battery management system controller side to take these decisions. Okay. So as I said, we are responsible by developing these onboard charger, DC-DC converters, as well as the battery management systems, high voltage junction boxes. The battery pack and motors are okay. Usually depend on the OEMs like Volvo, Geely, Mahindra. So they have their own contacts for having battery pack. Now in in this case, Chinese battery packs are mostly used. Okay, so this is all about what I also do in terms of electric vehicles. Okay, so just for you to know. So these are the components in the electric vehicle. So as I said, I think this is also explained here. There could be a AC or DC charging socket. So there are a couple of things. Okay, so if we do or if we charge it through AC, certain vehicles have AC chargers. So then we need a onboard charger to convert AC to DC. Okay, if it's directly DC charger, then we don't need onboard charger. So directly DC will be passed to battery pack. Okay, so the direct charging will happen. So there will be this will be the battery pack. Then there are DC to DC converter, as I said, that will convert this high voltage DC to low voltage 12 volt DC. Also there are inverters for converting DC to AC. So these are the main components of any electric vehicle. And as I said, thermal management is top most important here, because we are having high volt DC. So we are dealing with 800 volt DC. Okay, for example here, and if because of this heat dissipation happens, and there are chances of thermal gas event. Okay, in electric vehicle. So thermal management is also top important here. More or less clear about electric vehicle, its components, how it communicates internally. Any question here before we move ahead?
No, Pravin. You may continue.
Continue. Okay, thank you. So now we will talk about the communication protocols in EVs. Okay, what are the communication protocols? So till now we just discussed about what are the components inside the electric vehicle, try to get a flavor of it. And now we will go to the communications in EVs. Okay. Hello. Hello. Can you hear me?
Then details.
Hello. Is someone talking?
No. You continue.
Okay, I continue. Okay, thank you. So communication protocols in electric vehicle. Okay. So now there is a lot of boom on electric vehicles. Lot of giants are entering into the electric vehicles field. No. So when we are talking about innovative aerodynamics, lightweight materials, okay, powertrains and all this, okay. So there are a lot of features also in electric vehicles. So people, okay, now or the OEMs are started to invest more and more in electric vehicle. So and there are certain advantages also, like we will have although the cost of the electric vehicle is a bit higher, but the mileage we get, okay, in terms of IC engine vehicles, it's different. So it depends. Okay, now a lot of OEMs are now already investing in electric vehicles. So it's important to know how they can communicate. Okay, uh, within the vehicle as well as the outside world. So much of an EV's ability to function, like from driving to charging, depends on the electronic communication protocol. So the communication protocols plays a vital role, okay, in electric vehicles too. So we will talk about what are these communication protocols, okay, in electric vehicle. So I don't know whether you heard about controller area network CAN protocol, because it might be there in syllabus also. I don't remember, but most of the EVs rely on controller area network protocol for communication between vehicle components and external systems. We will talk more detail about what is this CAN, but yeah, this communication controller network protocol, CAN protocol, is used widely in electric as well as non-electric vehicle. Okay, then there are certain protocols like Modbus and LIN, which are also used by some auxiliary vehicle components. Here auxiliary means they are like, okay, not the master is used, but there are certain functions, okay, inside vehicles, so they are using it, okay, where there is no need of real time data communication. Okay, so in this case they are using the LIN, because CAN is costlier than the LIN or Modbus. Okay, then there are certain protocols like CHAdeMO and CCS have also the crucial role in fast charging. Okay, so they are there, CHAdeMO as well as CCS protocols, they are playing a role in the charging. Okay, now we have new protocol, I will touch upon that also, which is called as a NACS, North America Charging Standard. Okay, this is recently launched, and which is the protocol from Tesla basically. And there is protocol called as ISO 15118, okay, which enables bidirectional charging and vehicle to grid integration. Okay, and Ethernet also. So Ethernet is a one-stop solution for all high bandwidth data communication, like video streaming, infotainment, ADAS. So EVs are having these kind of features, like they have a big infotainment screen. Infotainment screen, I mean to say the display, okay, in a vehicle. So they are also having ADAS. I hope you know ADAS also in vehicle, because now in many higher end cars we get ADAS feature also. So this is talking about a lot of cameras are there, we can be able to view 360-degree of vehicle, ADAS is guiding how to park the vehicles and all. Okay, and there are another protocols like Wi-Fi and Bluetooth, which are used when we are connecting the smartphones, okay, to the AV. So we will touch upon each protocol in a bit detail. Okay, so let's talk about the CAN. Anyone knows anything about CAN protocol, controller area network? Is it already in the syllabus, or I don't know, I don't remember. Sir, do you know?
Actually, at the starting of FDP, there is a session on CAN and Ethernet.
Okay, good. Thank you. So yeah, as you might have learned more there, because my main focus will be on vehicle to grid, but yeah, also I'm covering the protocols which are required for battery management system and inside electric vehicle. So the CAN protocol is a primary protocol, as I said, in most of the vehicles, not only electric but also in non-electric vehicles. All North American and European automotive manufacturers like GM, Ford, Volvo, Skoda, all, okay, they rely on the CAN bus technology for engine management, safety, comfort features. Okay, so most of the ECUs, I mean ECU means electronic control modules, they are communicating to each other with the help of CAN. And there are also luxury and premium vehicles, okay, have fully integrated CAN systems. And there are certain budget friendly models, okay, which rely on lean but not on CAN. So CAN also comes with certain cost because of the high bit rate of the CAN. But yeah, 70% 70% vehicles are already having this protocol, okay, CAN protocol. So CAN basically is the backbone of all modern vehicles. It allows various electronic control units such as engine, airbag, body control modules, telematics, ABS to talk to one another in a real time. This is most important. The different electronic controllers I show in the first slide, they're talking to each other through this CAN protocol. So they are sharing some essential information so that vehicles run smoothly and safely. So it's also used in certain industries, like it's also used in avionics, aerospace, medical domain, automation and all, okay. But yeah, in automotive vehicles it is widely used. So what is CAN? So basically it's a two-wire communication, okay. So if you see here, different ECUs are connected through two wires. One is CAN low and another is CAN high. So here, if any ECU want to transfer any information, so this ECU will wake up this bus, CAN bus, and transfer it in a broadcast way. So it's a broadcast communication, okay. So if ECU transfers anything on these lines, all ECUs will get this information. And if the information what has been transferred by this ECU1, if it is intended for the ECU2, then that ECU2 will accept it and process it. If it is not intended for that ECU, then it will not accept, it will ignore. So whenever ECU1 transmit any information, it transmit together with the identifier of the ECU, okay. So for example, if I want to give a real-time example, okay, I will try to give a real-time example. You know that our any four-wheeler is measuring the vehicle speed, right? So vehicle speed is getting measured, agree? So we see the vehicle speed on tachometer in vehicle, right? How much at which speed we are driving the vehicle, we see that, right? Hello.
Yes. You continue.
Okay. So you know the vehicle speed. Okay. This is the vehicle speed is taken by one ECU. Okay, and it transmit that vehicle speed to another ECUs. So for example, vehicle speed is measured by one ECU called the ECU which is a cluster ECU, for example, which is an instrument cluster. Then it transported vehicle speed to all ECUs like body control module, lighting module, seat control module. Okay. So then, for example, okay, I am developing the seat control module. Okay. So which take cares about the seat movement and all. Okay. So what I will do as a seat control module owner, I will take that vehicle speed information from the cluster ECU. Okay, and what I will develop algorithm like, okay, if this vehicle speed is greater than 5 km/h, I will restrict seat movement for safety. So if vehicle is moving at a 5 km/h or more, I will not allow to move the seats. So for that, I need real-time data, right, from that another instrument cluster ECU. So the CAN is the protocol which helps to transfer this real-time data. Another example could be, there are different modes, power modes in a vehicle, like accessory mode, ignition mode, driving mode, right? If we are having the key, we rotate the key, right, to make it on accessories, ignition. So if we are in accessory mode, certain features work usually, like infotainment works, like we can able to switch on the radio and FM, all this, okay, but we cannot able to switch on the wipers, example, in accessory. So if we try to turn to ignition, then wipers are getting switched on. So this power mode of the vehicle. We call it as a power mode because it supplies power to the different loads, okay, in the vehicle. So this power mode information is transferred by body control module ECU to another ECUs. Accordingly, they take the decision. Okay, so the CAN is the protocol where this real-time communication happens between different ECUs, and it needs to be real time because if, for example, I am driving a vehicle at a speed, then if I am driving a vehicle at a speed of 20 kilometers per hour, and if I am allowing seat movement, there will be dangerous. Okay, it will be dangerous. So these all communication should happen in real time, and CAN is the protocol which helped to do this. And if you see here, what CAN is having, basically it's a two-wire communication. It has a CAN transceiver and CAN controller. So CAN controller usually is part of microcontroller unit, and sometimes the CAN transceiver also comes together with MCU. So MCU, some MCUs already having CAN transceiver. So this is a CAN transceiver, is a physical layer, and here it's a controller. Okay. So this is a kind of data frame. Okay, how it is. Maybe you might have learned in the previous session, like it is having a start of frame, identifier, the data length, also the actual data, CRC, and acknowledgement. So this is the protocol. Okay, how we need to send the information over CAN. But as I said, it's a real-time communication. So like conventional vehicles, CAN is also important in electric vehicle. Okay, which communicates between different battery management system and other vital components inside the electric vehicle. Okay, so then I will go to the next slide. So as said, CAN provides a vital link between battery management system and other systems inside the EV. Okay, so where the battery health, temperature, battery remaining charge, we should now know how much charge is remaining, right? And that information should be transferred real time. So if BMS calculate this remaining charge, it needs to be also transferred to the ECU which displays that information, right? So like infotainment or cluster. And this bus also facilitates communication between the battery pack, cooling system, EVCU, and helping to manage the battery temperature. So as I said, battery temperature is needs to be monitored very strictly in electric vehicle. And CAN is a protocol, okay, which help to communicate the battery temperature and all, okay, in real time and fast way. And also CAN further enables other safety features like regenerative braking, traction control, and electronic stability control also. And this bus allows real-time communication between braking system as well as the motor controller. So there is a term called regenerative braking. Okay, so in conventional non-electric vehicle, okay, when we apply the brake, the energy getting generated, but this energy is not used. Okay, but in hybrid or hybrid vehicles mainly, if we apply the braking, then there is a possibility to generate the energy and charge the battery through regenerative braking also. And CAN controller or the CAN communication also helps, okay, to apply this. As said, the CAN is essential for communication between the electric vehicles and the charging stations. So it's not only it communicate between all the electronic control modules, but it also helps to communication between the electric vehicle and charging stations. So this is also protocol, okay, used between the electric vehicle and charging stations. So together with other protocols. So now we will see also later there are some new smart technologies like V2G. They also use the CAN communication. Okay. With this help, EV optimize the energy use and intelligently regulate their charging and discharging response to the grid demand. So CAN plays also vital role here. So in communication. So in short, the CAN protocol, okay, is the one which communicate inside vehicles with different issues in real time, and also communicate from the vehicle towards the charging station. So yeah, this is all about the basics. Okay, of the CAN, how it is used inside the electric vehicles. Any question till now?
No.
Okay. Good. Then let's talk about another protocol which we call it as ISO 15118. Okay. So this is the international standard. Okay. Maybe usually suppliers like us, okay, we purchase such standards because we are developing the electronic control module, so we should know the details about each protocol and how it is. So we used to purchase this standard, so I cannot give you a lot of information on this because it's confidential to our company, but yeah, I will try to give you the only overview. So this is the international standard, okay, that addresses communication between electric vehicle and its infrastructure. So basically vehicle to grid communication. Okay. So it's a standardized interface, okay, which enhances the interoperability between manufacturers and charging stations. This has mainly two components. One is a electric vehicle communication controller. We call it as a EVC. So this is the controller inside electric vehicle. And there is a supply equipment communication controller. So this controller is within the charging station. Okay. So here the EVCC is the controller within the vehicle that handles communication with the charging station, and SECC is a controller within charging station responsible for the communication with EV. So this ISO 15118 is a protocol which takes care of communication between the EVCC and SECC. So between electric vehicle and the charging station. So here by using this standard, okay, electric vehicles can receive power from charging station, and it can send back power to the grid. Okay. So this V2G is now a lot of it's evolving technology, and a lot of companies, okay, now trying to support this. So this protocol is important, okay, nowadays from now on, and this is help to receive the power and also send back power to the grid. So this, if we implement this protocol at electric vehicle as well as charging station level, this will help to synchronize the power. Is help to receive the power and send back power to the grid. This also helps, okay, to adjust the charging based on the grid conditions. So it will take all parameters from the grid and it will try to balance the charging, like user preferences and energy tariffs, optimizing energy uses and cost. Additionally, the protocol supports automatic authentication and payment using digital certificates, eliminating the need of RFID cards and manual interactions. So this protocol can be used in different ways, okay, at charging station, like automatic authentication of vehicle, the payments and all, okay. So it said that it's highly protected, okay, against unauthorized access. So the cyber security plays a vital role here. So this protocol, is talking to electric vehicle as well as it talking to your payments and all, okay. So it said it's secure, okay. So we'll talk more on this later, what is vehicle to grid communication and all, but yeah, this is the protocol, okay, which is used for the communication between electric vehicle and charging station. Going forward, CHAdeMO. So I don't know whether you see or you have seen any electric charger, but this is a typical image, okay, a typical chargers, okay, what we see in the market. So if you see, here is a ground, then charging enable, disable, DC. If you see here, CAN low and CAN high. So as I said, CAN also plays a vital role in charging startup, okay. These are the basic connections of the CHAdeMO charger. So CHAdeMO basically, charging demo. It's a Japanese based fast charging standard in EVs. So it supports AC as well as DC charging. Okay, it's allowing the rapid vehicle charging. So as I said in the previous, the first some images, like the electric vehicle can take DC or AC input. So this charger is having capability of doing giving input both AC as well as DC. Okay. So compared with the widespread AC charging in public stations at home, it uses unique direct current method that charges batteries exceptionally quickly. So if we charge the batteries directly through DC, it's always a quick, okay? Because if we charge through AC input, then AC needs to be converted to DC by AC to DC converter, and then again it needs to be charged. But if we charge it through DC directly, it's always a fast charging, okay? So while many stations already run at roughly 50 kilowatt, CHAdeMO can deliver up to 500 kilowatt of electricity. It means that EV battery can be charged to 80% full in 30 minutes. So you know the main concern, okay, of electric vehicles, it takes a lot of time for charging, okay? And if we charge it our end at our home, okay, so we usually what we do, we have the AC plug, then we are giving AC directly to the electric vehicle, and inside electric vehicle there is a AC to DC converter. But with the help of this CHAdeMO, we can directly charge through the direct DC. So you can say in less than 30 minutes we can able to charge 80%. Then the typical 4 to 8 hour charge. So what we know, right? With the AC charging, it takes 4 hours, 8 hours, depends on the vehicle. Okay. So with the help of CHAdeMO, which is a fast charging standard, okay, which contains V2G. We will see more detail what is V2G. But yeah, so CHAdeMO has the capability of V2G also. So then CHAdeMO basically, okay, this is Japanese standard, so it is been widely adopted in Japan, China, and South Korea. This is not mainly used in North America or European markets, okay, and it's unlikely that okay this will be adopted. But yeah, mainly the South Korea, China, and Japan, okay, they are using this CHAdeMO charging method, okay. So in Europe now we have CCS. We will see what is CCS, but yeah, that is still upper hand, okay, in the charging market. This is all about the CHAdeMO. CHAdeMO, as I said, it's a fast charger which can directly charge DC. Less than 30 minutes, we can able to charge 80% of full EV, and mainly adopted in the Japan, China, and South Korea. Can you move to the next? Are we here?
Yes.
Okay, good. Then we will go to the next charging standard, which is a combined charging system, CCS. Okay, again, this combined charging system is also capable to charge DC as well through DC as well as AC, okay, both. But as I said, this is mainly used in the North America and Europe, this CCS charging system. So if you see, the connectors are different. So if you see, this is the connector for CHAdeMO, and if you see that this is the connector for CCS. So this connector is how we connect directly to the electric vehicle. So it has certain control pilots, some proximity detection. So it has certain features. Okay. So as I said, it's mainly used in North America and Europe. And then if you see comparison here, also in North America and Europe, there are connections are more or less same, but the sockets are also having certain differences, okay, for AC and DC. But the standards, the protocol is same. So it uses a unique dual port connector to accommodate both AC and DC charging. A CCS equipped with EVs can access any compatible charging station regardless of its power capabilities. So it can support up to from 20 to 350 kilowatt depending on specific implementation. So higher power levels facilitate expedited charging durations and the establishment of ultra fast charging infrastructure. So yeah, this is again this CCS is can also do the fast charging like CHAdeMO. So it's used in North America and Europe for. So if we directly connect DC, it can do the fast charging. And then the CCS relies on standardized communication protocols between EV. So there are protocols like, as I said, ISO 15118. This is for the vehicle to grid communication. So CCS supporting this already. It's also supporting the IEC 61851, which is the charging station communication. So and it's also supporting Open Charge Point Protocol OCPP for managing communication between charging station as well as the central management system. And it supports the TCP/IP, okay, which is the internet communication for data exchange between EVs and charging station for authentication, billing, and monitoring. So like other protocols, like this, it can also support on automatic authentication, billing, and monitoring inside charging station. Also the full duplex communication between EVs and charging station. So CCS is already in market. It's widely used in North America and Europe, and it's having a lot of monopoly, okay, in the market. The CCS also can be used in the current infrastructure because of its backward compatibility. So it implies type 2 AC charging as well as the DC charging and all, okay. So it's compatible for older vehicles also. So the connector is developed like this. It can satisfy the new vehicles as well as the older ones, because in certain vehicles, okay, we are only having this type of connection, not the DC. So it can satisfy only AC, also satisfy combination of AC plus DC. So this is a backward compatible basically. So yes, so this is the currently a protocol, okay, available for the charging. Then going ahead, I will introduce this new one, okay, which is called as a NACS, North American Charging System. And this is the protocol now we are working, okay. It's still not introduced in market. The work is already ongoing. So as we are developing battery management system, onboard chargers and all, okay, we are now studying this protocol and trying to make our products, the battery management system, onboard chargers compatible to this protocol as well, because now previously we were compatible with CCS, we are compatible with CHAdeMO. So the management system what we are developing inside our company, they are already satisfying CHAdeMO and CCS. But now what happened in the recent 2-3 years back, okay, the North American, okay, accepted the Tesla charger basically. So Tesla developed this protocol, okay, North American charging system, and now it is adopted by many OEMs like Ford, GM, Volvo. So all big giants, okay, they now already accepting this Tesla charger. So the difference, okay, here is this is the conventional CCS. What I see here, this is the CCS having DC, AC, and all, okay. So here in upper part you see line and neutral, which is the AC, and lower part it's a DC. This is the conventional CCS, okay. But in NACS, North American charging system, which is developed by Tesla, AC and DC are coming on the same lines, okay. So only one port, this is responsible for DC plus AC both, okay. So it's whenever we are studying this protocol, it is too complex, okay, because as a ECU developer for us, we are getting DC and AC on the same lines, okay. And then we need to identify which is DC and which is AC, because if we say 230 volt is AC, but here DC is also about 200 volt. Okay, so it's a bit challenging first to identify what is DC and what is AC, and to develop a system or our hardware such a way that it should withstand whether we get DC or AC on the same pins. Okay, so basically the NSCS uses 5-pin layout. 2 primary pins are used for both AC and DC charging, fast charging. So this is again the fast charging method, and as I said, this is developed by Tesla and a lot of other OEMs. The countries are already now adopting it. As per as my knowledge, Volvo committed that they will provide their vehicle NACS compliant by 2025 end, okay, something like that. So almost in couple of years, okay, most of the vehicles, okay, in the market will have this capability of NACS. So we can able to directly connect Tesla charger to Volvo vehicle, Tesla charger to Ford vehicle. Okay, so how this is what we will have. So because the charger will be same maybe, but the vehicle brands can be different. We can able to connect Tesla charger to Volkswagen, Skoda. Okay, so this is how it is. So almost all brand, they accepted the Tesla charger, and they are now working in a way how they can adapt to this Tesla charger. So accordingly, they are developing that, are modifying their onboard chargers, their battery management system, their battery packs, their high voltage junction boxes. Okay, because the main problem or the main complexity here is AC and DC coming on the same line. Okay, then this pin DC plus or L1 provides either the positive side of the DC voltage link, or when using AC it provides a line in split phase connection. Similarly, the DC minus or L2 pin provides the negative side of DC voltage, or when you're using AC it serves as a line 2. The G here is the ground, which provides the connection between the earth and the vehicle chassis. This ground pin is used as a reference point for the CP and PP signals. CP and PP are the control pilot and proximity pilot. Okay, these pins are used for communication basically. So the CP control pilot pin used as a digital communication path between charging system and vehicle. So this plays vital role for the communication between charging system and the vehicle. And the proximity pilot carries a low voltage signal and used to determine the status of the vehicle connector. So proximity is like it helps to detect the where is the vehicle connector and all. Okay, so these are the control pins of the charger. These two are the DC and AC pins, and another is ground. But as I said, this is something upcoming, and the work is ongoing on this. Okay, but now if you see in the market, you will see combined charging system CCS and CHAdeMO. So these are the two chargers which are widely adopted as a fast charging, as it supports fast charging. Okay, so these all are about the protocols or the terminologies or the methods, okay, for the communication between the electric vehicle and the charging system. Are we with me? Clear? Hello?
Yes, you continue.
Any questions till now?
No.
Okay, thank you. So as we are continuing the communication, Modbus is also one protocol, okay, which is not directly automotive protocol, but it is widely used in instrumentation. Okay, basically it's an industrial communication protocol, but in automotive also it used for certain things. Okay, like if there are certain loads auxiliary loads and all, okay, they use this Modbus. So if there is a master issue, for example, we have a body control module issue, and to that issue there is another switch is connected, a door lock switch is connected. So if there is any other issue, okay, which is only communicating to that particular body control module or engine issue, then this low cost communication protocol is used because it's a simple, cost effective. So in certain issues it is used, okay, but this is not most widely used in automotive or in a vehicle. But yeah, in certain places, okay, where there is only point to point communication, it's not required a real time communication, okay, in or some aftermarket features, okay, like battery if we apply battery gauge or some diagnostic tools, okay, then they use this Modbus communication protocol. But yeah, as I said, this Modbus is mostly used in the instrumentation and all domains. But yeah, in certain cases it is also used in automotive. The benefit of Modbus, okay, is that it offers reliable communication over long distance. This is the benefit, okay, because it's the reliable communication protocol for long distance, okay. So for example, we are having electric tractors, okay, or some construction equipment, okay, or heavy duty trucks. They can rely on the Modbus to communicate the external devices like diagnostic tools, charging systems, specialized attachments. So for example, we have a big trailer, okay, and if we switch on the lights, for example, okay, so then that command should be given till end of the trailer, right? So all the lamps, okay, which are there till end, if you want to keep it on, so the distance get increased, okay, for the tractors or trailers. So in such case, Modbus can be used as it is a reliable communication for the long distance. Otherwise, it's not used, okay, in our normal passenger vehicles. But yeah, in certain cases, as I said, it can be used because of the cost effectiveness and it's a reliable communication for the long distance. Okay, and this is also one of the communication protocol, okay, which is used. Okay, another protocol, okay, which is communication protocol which is used in the automotive is LIN. Is there anyone heard about LIN previously in any of the lecture?
No. It's
No.
a new concept.
Okay, then I will talk more on LIN because it's also an important communication protocol, okay, inside a vehicle. How many you see in Mahindra XUV700? Mahindra XUV700 top model. Do we know this vehicle? Mahindra XUV700.
Hello, Pravin.
Yes.
I have my one of friends. That friend is using Mahindra XUV700.
Okay, good. So in Mahindra XUV700, in Mahindra XUV700, okay, the seat system is developed by our company, whole seat system, okay. So it has a feature, maybe I don't know whether you know this because I am the product manager at that time, okay, to develop this feature. So if you open the door, seat automatically comes back. If you close the driver door, the driver seat automatically make it to his original position. So this is automation we did. Like if someone want to enter into the car, a driver, if you open the door, then seat comes back. If he close the door, again seat comes to his own original position. And in the door side, okay, there are certain switches like memory switches, okay. Through that switches now you can able to store your profile. So for example, now you sit in like this, okay, I adjusted my seat, and then if I switch press M+1 button, okay, so it will store all your profile of steering, seating, height and all in that one memory position. Now today Kali sir is sitting, now tomorrow some another person or I came in the vehicle and I do seat adjustment according to my convenience, and then I press 2. Then there is another driver, he does the setting as per his convenience and he press 3. So whenever Kali sir comes again, and if he only press recall that one, seat will be automatically adjusted according to your stored profile. Okay, if I came, it will be according.
Yes, 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 yes.
ठेवल्या मालकाचा
Okay.
आहे.
There are different positions, I think, according
Yes.
to the driver.
Yes. So then in this, okay, because I am the, as I said, I am the product manager for this all.
No, actually, there are different, for different person, we can
Yeah.
save different seat positions.
Correct. Yes. Yes. Correct. So how this communication happens then? Okay. So as I said, seat is developed by our company Lear. Inside, so if you see below the seat, there is a controller called seat control module. Okay. So seat control module is another electronic control module. Okay. Which is a lean master. Okay. This is the lean master, and the switches, okay, which are there on the door side. If you press that switch, accordingly action happens. These are the slaves, lean slaves. Okay. So these lean slaves, the door switches, which are, we can able to move the seats and store the positions. These door switches are connected to seat control module, which is below the seat in vehicle, through lean communication. Okay. Okay, this is a real-time example which I already worked upon, and it's in market already. And so that I want to take that example because you can able to correlate. So here these switches, okay, are only communicating to the master. They are not communicating to any other issues like body control module or engine control module, because their function is limited to seat. And all other seat functions like this master, okay, for example, seat control module is managing to move the motors and all. Okay. So the seat control module is taking inputs from these slaves like switches and pass it on to the electric motor. So there are certain sensors from seat motors. Okay, the motors which are responsible for the seat movement. So this lean master monitors all the positions and all. Okay, but the input for lean master is from the slaves. So this is a single wire communication. Okay. Again, it's not like that much complex like CAN. Okay, because here the slaves, okay, slaves only listen to the master. So, and as I said, it is used for the certain loads like door locks, windows, mirrors. Okay, so this kind of communication happens over the lean. It's cost effective than CAN because it involves less efforts as well as the less wiring and all. Okay, so and it's a point to point. Okay, and it is used for some auxiliary features. So the best example here, as I said, the seat control module and the switches. Okay, how they communicate and interact. Then it's a serial communication protocol. Okay, for the interaction between the controller, different controllers. So this lean is playing a supportive role in the communication. So it's not a main or the major or the vital protocol in automotive or electric vehicle or any other vehicles, but yeah, it's a support, playing a supportive role to the CAN, for the CAN. Okay. So there could be different issues which are communicating over CAN. So this lean master is also communicating over a CAN with different issues. But if there is a command for the slave, it cannot directly goes to the slave, but it will go through the master, because master is capable of both CAN communication as well as lean communication. But slaves are only capable of lean communication. Then all the commands which are required for slave will be from master only. So if there is another issue which is asking something for seat control module here, they will listen it and they will transfer it to lean to the slave if slave needs to act. Okay. So how it is? It's a simple serial protocol, and yeah, it helps to data exchange between the low power microcontrollers. And it's as I said, it is in conventional cars, lean protocols are used for door locks, windows, mirrors, seats, lighting. Okay, heating and ventilation. So nowadays there's a feature in the seat also. Okay, so you can able to heat as well as cool the seats. Okay, so these heating ventilation modules are also lean slaves. Okay, usually. So these are also controlled by lean master. So what happens here? If I am a Mahindra and Mahindra, okay, I am a customer, okay, and I want to develop this seat control module together with heating, ventilation, memory seats, and all. Okay, so what I do, I develop a lean description file. Okay, lean description file contains all the information for lean master and lean slave. So for example, lean master is now done by my company from the layer. Okay, the door switches or the heating ventilation is not done by layer. So this could be done by some other companies, Consberg. This can be done by another company, Aptiv, for example. But what customer or the OEM gives a lean description file to all the companies. Like lean slave 1 is developed by some company, this is by another company, and this is by me, for example. Then this lean description file is given to all the nodes. Okay, and then they accordingly adapt to that. So this is how the OEM or the vehicle brand, okay, they give the information. So and they will say us, okay, you need to satisfy lean XYZ standard, lean 2.0, 3.0, whatever. Okay, so then accordingly the communication development happens, and then we directly test on the vehicle also later. So I said this is a protocol which is suitable for low speed application in non-electric vehicles also. So if we see here, first it happens synchronization and then the data message. Okay, so first all these are synchronization field in the message header and then the data and response and checksum. So it's a single wire point to point, so it's not a broadcast way, but used for auxiliary loads, okay, in the vehicle. So this is okay, brief about the lean. So the speed here is, we talk about 250 kbps or okay, maximum 120 kbps. But if you compare with the CAN talks about 1 mbps, 8 mbps, like this. Okay, as I said, CAN needs a real-time information. So if we want to compare, okay, if I want to take any safety action, okay, in a vehicle, we should get that information very quick, real time. But now if we compare with the real time example of seat, okay, so if I press a switch and for one press, for example, seat doesn't move, it is not going to harm you, right? You can still able to cope up with that. So for that, you can again press 2 times, for example, then it can move. So these are kind of features, okay, which are not safety critical, and for the moment we are choosing at that time lean. But for safety critical features we cannot choose this because this is the protocol which is not high speed protocol. Okay, but at certain features, if you start cooling, okay, if you expect to have the cooling in 10 seconds but it takes 11 seconds, no one is going to die. So this is how we choose between the protocols when based on the application. Okay, then we will talk about, I think there you already said there is a session on Ethernet. I will just give you the brief, okay, about Ethernet, how it is used in the vehicle and that perspective, okay, because you might have learned most of the things of Ethernet. So basically, Ethernet is a prominent technology in computer networking, now also getting used in electric vehicles. So the ADAS, okay, the ADAS features, okay, they mostly use Ethernet, okay, to analyze the data in real time because with more accuracy. It also does the data exchange between cameras, radar, sensors, okay, for enabling the collision avoidance in departure and lane departure warnings, okay, and adaptive cruise control. So these are the new features like collision avoidance, lane departure warning, and adaptive cruise control. I think you might know this cruise control also, maybe, because most of the cars now already have it. So Ethernet plays a vital role, okay, on these high-end features, basically, where the real-time data is required with more accuracy and high speed. So in electric vehicle, Ethernet also can be used for data exchange between battery management system, electric motors, and other components in real time for monitoring the battery health and performance, which helps to maximize the efficiency and minimize the charging times. Then Ethernet also works on the V2X communication, so vehicle to everything. We will see later, okay, what is V2X. That enables the car to car and car to infrastructure. So in V2X, okay, your electric car can communicate to another electric car, and also your electric car can communicate to the infrastructure. So this allows, okay, to share information on traffic conditions, charging stations, and road hazard. So now also Google are asking, okay, if you have any hazard, so we report it to Google, right? Sometimes, is there any collision there? So they are asking this because if there is a previous collision, they are also taking the inputs from you, right? And they are asking us whether it's still there or not. So like way, your electric vehicle can communicate to charging station, can communicate to another. And this Ethernet, okay, again facilitates the over-the-air updates in various EV systems. Does anyone know what is over-the-air update? Have you heard about it over there, sir?
Yes, yes. In computer networking, we use
In computer networking,
Hmm.
for what purpose?
networking concept.
Networking concept, okay.
Bandwidth to achieve the more bandwidth.
To achieve the more bandwidth, okay. Okay. In vehicle, okay, over-the-air update is like, okay. Now, for example, your electric vehicle or any conventional vehicle, if your electric vehicle is there with certain features, okay, like you purchase the vehicle with certain features, but let's see, we have certain new features available, okay. So in such case, okay, the vehicle brand and the OEM ask, okay, whether you want this feature or not. If it is only software wow feature, okay, what they do, they update your vehicle software when vehicle is at your home through internet. Getting? So your vehicle is having certain software version, okay, with certain features, but suppose in down the line in 1 year or 2 year, they develop certain new features, okay. So they can tell, okay, if you want this feature, we will update it on your vehicle with this much cost. So if you agree, then they will not come to your home for that. In certain vehicles, I'm saying, they will directly push that software update through internet, and your vehicle ECU will be having the new software with new feature, okay. This is how it is. So this is not only used for updating the new feature, but sometimes, okay, what happens now, for example, I am developing a battery management system ECU, okay, and the vehicle is in the market, okay, for example, now Volvo, example, take example of Volvo, okay. So I am delivering battery management system to Volvo from last 3 years, okay. Volvo produced around, let's say, in the 3 years 150k vehicles, okay, in Europe and America. Now these 150k vehicles are delivered to 150k different clients or the customers, okay. So if there is any issue or bug in my software, okay, for my BMS software, okay, I solved that bug because certain bugs are reported by certain user, not all, but then after we realize that, okay, this is a serious issue and that needs to be solved. Then now imagine you have 150k vehicles already sold in a market. Is it really possible to go individual home to refresh this new software because it solves that bug? Is it really possible to go at everyone's home and refresh the vehicle with the new software to solve that bug? It's difficult, right? We need to find each and every owner where it is. Or another way is ask them to come to the dealer. Certain times recall happens. Do you remember? If there is an issue, Mahindra or Tata or anyone, they ask for owners to go to the dealer and they do the certain updates. So it happens only when there are serious issue and that needs to be immediately need to be taken care, okay. But certain things, okay, what they do, they push this software over there. So what they will do, whenever your vehicle is connected to internet, it will receive the updated software, okay, and then it's us, okay, we should accept it, and they will reflash the new software in the vehicle, because every time it is difficult. So these over the air updates are already available in certain or most of the vehicle brands for higher end vehicles in Europe, America and all, okay. In India, I think it's still not there, so they are calling you on dealer station, right? Most of the time, but it helps a lot, okay, it helps a lot. So, because we don't sometimes, okay, you don't know what they solve, okay, so they are solving a lot of things and we don't know, and we don't need to go to dealer also. So it also easiness for user, okay, they updated something good, but yeah, we don't need to go to the dealer, and it's a pure over there software update through Ethernet. So and then as I say, Ethernet is used for video streaming and all, okay, but yeah, this is a very crucial feature. And the vehicles, okay, what I am working for certain brands, they are already having this feature. Okay, last one in the communication, okay, it's a Bluetooth and Wi-Fi, okay. So you know the Bluetooth and Wi-Fi protocols already, so they are wireless protocols. And so for example, you want to connect a smartphone to your vehicle, it uses the Bluetooth communication usually. So whenever you go to any service station of vehicle, okay, usually what vehicle service station they do, they connect one connector to your vehicle, okay, where the connection is below at right side of steering wheel. If you see the steering wheel like this, in the right side below you will see a connector. So they connect that connector and they read all the information from your vehicle. So what that information is, that information says what are the faults in your vehicle. So we call it as a diagnostic trouble codes, DTCs, okay. So they read all the diagnostic trouble codes, and accordingly they do the correction in the vehicle. So we call it as a onboard diagnostics, OBD. So this is in conventional vehicles or electric vehicles. Previously it was like we need to connect that particular connector in a vehicle, and then only you can able to read all the fault codes, okay, from the vehicle. But nowadays these scanners, okay, are also wireless. They can be connected via Bluetooth. So that is allowing the access of the, we can able to get the battery health information, engine information. Also there are any fault codes are there. So we can able to get all the information through the OBD2 scanner. And as you know, the Bluetooth is used to connect smartphone, hands-free calling and all, okay. So this is there. And Wi-Fi, okay. Wi-Fi is also one, okay, which is helping to install the over there updated softwares, okay, inside EV. So I already talked about what is over there air updates. So Wi-Fi can also be used, okay, to install the software inside your vehicle. Sometimes what happens at the time of Christmas, okay, what this vehicle manufacturer does, they push one software in your vehicle that will show certain features that, okay, you are getting now these features for 30 days. So they will push that software with the new wow features, okay, for 30 days, and then they will again push the previous software. So then in 30 days you will see if you really want this feature, then come to our end, and yeah, they will permanently push. So they will charge something for that features. But you know the way Reliance and all this doing, they first made the data free and all, right. This is also now automotive manufacturers are doing. They are pushing certain features, okay, for certain limited period of time, and they make sure that people may make use of it. And you know, if people get habitual to it, they start charging money, okay, through this also. This is also no getting new business strategy, okay, like this. The Bluetooth and Wi-Fi also, these are the protocols which are used in the electric vehicle. So this is all about all the protocols in terms of communication. Now the last point remained is about vehicle to grid. Before moving ahead, is there any question on the communication protocols what I showed?
No, no.
Clear enough
Yes, yes.
at higher level? Okay, perfect. Then I will continue. So next main topic, okay, also what we want to touch upon is what is vehicle to grid. Have you thought about this before or not? But V2G or the vehicle to grid enables energy to flow both ways, like from electric battery to power grid. So we know that, okay, how the charging happens. So we take the AC from our home or grid or charging station, and then we charge our vehicle. But here V2G help to push energy back to grid. So it's not about charging, but it's about giving energy back when it's required. So it's called as a bidirectional charging. So here usually this is the power grid. Then we have the transformers, right, in each area. Then there are certain power converters, and then this is the charging station, okay. And then charging from the charging station, electric vehicles are charged. This is the one flow, okay. But you see that electric vehicles are having higher capacity batteries, and they are storing a lot of energy inside that. So whenever is required, they can push back energy from their battery to this power grids, okay. So to meet the certain peak load demands. So V2G refers to the bidirectional energy flow. So not only taking energy from charging station and power grid, but giving back, okay, when is required. Clear? So basically V2G technology powers bidirectional charging, which makes it possible to charge the electric vehicle battery and take the energy stored in the car battery and push back into the power grid. So this is how it is in short time. It's a bidirectional flow. So this is about V2G, and there is another terminology called V2X. V2X stands for vehicle to everything. Okay. So it's not about only giving power energy back from battery pack or vehicle battery to grid, but we can think about giving energy back to your home or your office or certain loads. So for example, you are having an electric vehicle and you went for certain camping, and you realize that there is no electricity there. So what you can do? You can take back your energy from your electric battery, and you can have a certain load there that will help you to satisfy the need. This is called vehicle to load. And also imagine a situation, okay, where you are in home and you need power, okay, somehow because of, and you have already charged electric vehicle. So with the help of V2H, you can able to get energy back from your electric battery to your home. This is also possible. Then let's assume another case of V2B. It's a vehicle to building, okay. So imagine you have a big building, big office, okay, where lot of electric cars are parked, and then you can think of for drawing power from that all electric car batteries, making it for your office use, okay. This is also possible. So V2G and V2X all refers to the how we can give power back to your home, your office, building, or your any other load, okay. So don't think that, okay, your electric vehicle is only helping you to go from one station to another location, but it can also help you in a way to give you back power, okay, when is required. So in certain cases, okay, there are at at certain times, okay, there is a higher peak demand. So sometimes what happens, the power grid cannot able to satisfy that demand. So in such cases, we can identify such use cases, and at that time we can able to take back, if we can able to take back power from our electric vehicle, we can able to satisfy the demand. So whenever there is a demand is low, we can charge all electric vehicles at that time, so that we can store sufficient power. And whenever there is high demand, we can give back power to the power grid, or your building, or your office, or your home, whatever is possible. Okay, this is about the vehicle to X, vehicle to everything. So vehicle to grid is a one step further that enables charge power to be momentarily pushed back to the grid from car batteries to balance variations in energy production and consumption. This is still not implemented in India, okay, but yeah, the more work is ongoing on this V2X or V2G technologies, so that they can able to take back power from electric vehicles. Okay. Okay. Now, why should we care about V2G or V2X? Okay, it's important to know. So V2G helps to mitigate the climate change by allowing our energy system to balance. So basically, we have a lot of energy sources. Okay, one of is fossil fuels. Okay, which we know. So whenever we burn that fuel, the energy is consumed. So here we have a lot of sources. Okay, like renewable energy sources like solar and wind, which produces or which can produce a lot of energy. But the problem here is about the energy storage. So if we produce, for example, certain energy from solar or wind, there is always a problem of storage. So whenever we produce it, either it should be consumed on the same time, or it needs to be stored somewhere. But we still do not have infrastructure, okay, to store sufficient amount of wind or solar energy. So in such case, okay, we can think of having the energy from wind or solar, and we can store it in the electric vehicle battery. This is a, we can say, the storage source for renewable energy sources. So this energy should be either used when it's produced, or it is stored for later use. As renewable energy production increasingly makes its way into our energy system, it creates more volatility and a need of new ways of balancing and storing renewable energy. So think of, okay, if we are producing lot of energy from solar or wind, we can charge at that time the electric vehicles, and these electric vehicle batteries can be a tiny source of energies for future. Okay, so this will help a lot. And in 2020, 5% cars were electric, but in 2022 there are around 14% cars are electric. Okay, so day by day electric cars production is getting increased. So day by day we are getting lot of batteries inside electric vehicles. So you can think of using that electric vehicle batteries as a potential energy source for future. And this will help mainly when we use the wind and solar energy. So EV batteries are the most cost efficient form of energy storage, since they require no additional investment in hardware, because we already have the V2G compatible CHAdeMO charger, V2G compatible CCS, V2G compatible NACS. So the charging methodology already there. So there is no additional investments required if we want to go for V2G. And if I don't know, what we say always, okay, whenever you charge the battery, you should use it 100%, and then you charge again. So you should not keep charging and charging the battery. You should charge and discharge for the efficient use. This is how we say, no? If you are using laptop or if you are using smartphone, what we say, okay, charge it to 100%, then discharge it to below 10%, then only charge it. Otherwise, don't charge it with 90%, 80%. Okay, let's do the battery charge and discharge cycle. So consider like, okay, if we have a V2G where we can charge from renewable sources and we can discharge for our needs. So that charging discharging cycles, okay, that will also help to make battery life more, okay, the efficient life, okay, in this case. So this will help. This will help the battery life as well as it will help to store the energy for future use. So in 2030, okay, there could be up to 250 million vehicles globally. That means we have around 250 million tiny sources on wheels, okay. So research shows that at the end of this decade, EV batteries should be satisfied or should be able to satisfy the short-term need of energy. So this is all about V2G, V2X, and how we can make use of it for from the renewable sources. So we can solar panels we can give back to the grid, or wind we can give back to the grid, and another could be electric vehicle. Okay, we can think of storing the energy there and give back it to the grid or office or home. Okay, so now why we need to have this V2G technology? It is because many countries like United States, okay, they promise that they will reach net zero emission by 2050. And the current energy shift from fossil fuels to renewable energy takes many forms. So with solar and wind energy, this can be optimized. So now many countries, okay, now they are putting their self a rule like to have the net zero emission. So if they want to achieve the net zero emissions, they should shift the use from fossil fuels to renewable sources. And if they want to shift or they need to shift to the renewable sources, then they can think of using the battery in electric vehicle as a potential energy storage. So however, the renewable energy is a intermittent, meaning it's not always stable. Some sunny or windy days produce more electricity than we can use. So in contrast, cloudy or windless days reduce their output. So these variations cause headaches for grid operators balancing supply and demand. So all these problems, right? When you are using solar and wind. So one remedy to store excess renewable energy or any excess energy in the batteries and they release it when required. So there are around 40 million vehicles globally with 2.5 million in the US, and that number is expected to grow. That's a lot of battery capacity, okay, which can help to capture the renewable energy and redistribute it when required. So whenever we are producing more, in case of sunny days or windy days, let's store it in the batteries. So therefore, V2G vehicle to grid can be part of the world's electrification and decarbonization as we are transitioning from fossil fuels to green energy. So they become a battery storage mechanism that is currently lacking on the utility scale. The trick is to charge as many EVs batteries with renewable energy and make it and use it whenever it is required. Okay. So this is the need, okay, now for vehicle to grid. So we should focus upon zero emissions. We should focus upon how we can shift from fossil fuels to renewable energy. And electrical vehicle batteries are one of the source, okay, we can potentially store the accessible energy. Clear? Any questions till now?
No.
Okay, thank you. Now you are saying, okay, I am talking a lot on, okay, how we can do this, and why still it was not done, right? This is also a question, right? I am saying this can be that, okay, we can use this, but why then? Why we are not doing it, right? Who is stopping? Any guess? Who's stopping? Right? I'm talking a lot, okay? this can be like this. We will we will have zero emission. We will not use fossil fuels and all this. Okay, but who's stopping then? Any
Maybe
guess?
some of the government policies.
Mm-hmm. Any other guess? Yes, so let's talk about the challenges. Okay, why we are still not doing all this? Okay, basically the infrastructure. Okay, what we have. So our power grids are not ready for mass adoption. Basically, if every homeowner do the charging of EVs overnight, our power grids cannot supply that demand now. And also in terms of battery manufacturing, we are not producing that much batteries which is possible, or that are required because of the raw materials like lithium, cobalt, graphites. So these are found at unique places. So if we want to build batteries up to our wish, we cannot do so. It needs to be done at certain countries, at certain places. And also for the same, so solar panel cost already, it's not that much cost effective. So if I want to make my own house a solar electric, it takes me around certain lakhs to install solar panels, right? And then produce the energy and give back to the MSCB also. So the infrastructure, what is required for it, it's not that much cost effective and not easily available. So now if I buy a EV, and always there is a problem, right? How many kilometers it will run, right? They are asking, or they're saying, okay, it will run 300 kilometers, but really it is possible, or it really it is giving that much range, because the 300 kilometers might be on the smooth road, right? But now I am living in hometown, and the roads are not that much proper, or there are certain ghat section and all. So it's not possible, right? We can get that much range. So we need to have the in between charging. So there is always we think, for example, let's take example of Kalesar. Which vehicle you have now?
Baleno.
Baleno. Now if I tell you, I am giving you electric vehicle with 500 kilometer range, will you buy it immediately?
I have to think.
What thing? What you have to think?
Uh, how much time it will require to charge that
Okay.
vehicle.
Okay.
This is the first thing.
Yes. Okay.
And if I want to travel more than 500 kilometers, then also I have to think where
Think.
to charge this vehicle.
Okay. Good. And the cost, right? How much
Yes,
it is?
yes.
How much it cost? Costly, right?
Cost is also high.
So as I said, the infrastructure is not that much developed to have the EV vehicles with our affordable cost, right? So although I am saying all these things, it is not that much easy to adopt, because of, as I said, the batteries suppliers are unique. There are certain monopolies. Electric vehicle cost is not that much in affordable range. Also the limitation on charging in between, and if there are also chargers, it's also limiting the time it required to charge. So we should have the at least DC chargers, fast chargers. So at least it will take 30 minutes minimum to charge up to 80%, although it's a DC charger, right? So all these things are there to adopt electric vehicles and vehicle to grid technology. Although there are a lot of benefits, but because of these all limitations, it is not that much easy. So as I said, it takes a lot of time for charging the electric vehicles. So all the way it's expected that V2G will come to the picture very soon, but it's not in that time. So it should be already there, but because of all these limitations, it's difficult that we will focus on V2G, and it will help us, okay, as a energy source, and it will give power back to the grid and all, okay, because of the limitations. And also there is always a fear, okay, although there is a lot of safety functions in electric vehicle, you will think once, okay, burn ho gaya to kya yaar, pata nahi, life threatening, right? Always, because IC engine vehicles are proven from long many years, and you might heard some news like some vehicle is burned because all this, okay. So this also comes in our mind, okay, if we are buying a vehicle, why should buy the electric if there is no still stability, right? So there are a lot of advancements or innovation is happening there, but still people require a kind of stability if they are purchasing any vehicle, and with electric vehicle is still far, okay. So it will take certain time. Nowadays two-wheelers are popular, but still not four-wheelers. So four-wheelers it's taking still some more time, but long down the line in some years, okay, we will see a lot of electric vehicles. But yeah, so whenever there is a infrastructure available, India also will think about V2G, V2X, right? All these technologies. So then that's it from my side about electric vehicle, charging, communication between electric vehicle, communication between charging to grid and all. Now the forum is open for any question.
Participant, unmute yourself and you can ask question if you have any doubt.
Hello, good evening, sir.
Good evening.
This is Dr. Raghavendra from G3 Engineering College, Mysore, Karnataka
Okay.
State.
Yes.
I have one question.
Yes.
Everyone is telling that at 2030, most of the vehicles become EV. Will you agree?
No.
Is it possible?
It's also not possible, and say, as I said, if we take about any OEM, okay, let's take example of Mahindra, for example, in our India.
Okay.
How many vehicles they are producing electric vehicles nowadays? Now they brought new, okay, but by 2030 they might produce more, but full electric not possible.
Not possible, no? Correct, no, sir?
No,
Okay,
no, not possible. So
Thank you.
now maybe they brought new vehicles, 5 to 10% maximum. No, not 10% also. They are producing 5%, okay, electric vehicles.
Yes.
So maybe it will go beyond 50.
Okay.
But always they should stop. Do you remember the diesel case? Okay, so
yes.
they asked to stop diesel production certain time before, but still they are producing, and people are purchasing. Although there are certain bans on diesel vehicles, but why they are purchasing? Because they trust the conventional methods, right? So electric vehicles, it will take certain time to for people to trust on this vehicle. And as I said, the battery production, okay, it's also important because the raw materials for battery are coming from certain places. So yeah, but the definitely number will increase. Yes.
Kale sir, after
Also we have
valedictory
to.
program.
Ek minute, sir. Hello, sir. Just
Santosh sir,
Sir,
after valedictory program, we can
question.
fill the test, no? Take up test, no?
Yes, I will guide you. We will finish first of all valedictory, then I will guide you.
Sure. Thank you, sir. Thank you.
So my question is that so if EVs will increase day by day, then there will be a problem of disposing the used batteries also, no?
That is another big problem. Yes.
Needs to be addressed, that issue also.
Yes, correct. Yes, that is a big problem now also in front of us, because at the one end we are saying that okay, we are fulfilling the zero emission. We want to fulfill zero emission with Delta PV, but at the end, what will happen to the used batteries? I will give you one example, okay, good example, because I recently worked last year, okay. I got a request from, I will not tell the customer, okay. There is one European regulation, okay, which comes into the picture, which now talks about how we can use the batteries from the electric vehicle. For example, okay, the battery life is 5 years, okay, in electric vehicle. Then what we do after 5 years for these batteries? Because if it is a 800 volt battery, it will not perform like 800 volt, but it can be still there used, okay. So then I got one request from our OEM saying, you have the battery management system software. I think I talked about, okay, I am developing battery management system. I mean, I will show you in the figure, okay. So this is interesting question. So for example, here it's a battery pack with the controller, okay. So always they will after 5 years, for example, the battery life is exhaust or finished, they will take out the battery from the car, and what they said to me, I want to make use of this battery for any other application. Any other application means it can be used, okay, in not in vehicle directly or in car, but I want to use for, make it use for home use or any other use. So in that case, what I will do, or they asking me to do, please erase all the data specific to my car, erase all the software which is there in your controller, and make this controller clean, okay. So they ask me to develop a new software which will help to clean all the data related to that particular vehicle as well as the software. So what they will do now, they will again sell the battery pack with the controller, but that controller will be empty, meaning no software inside, and that they will give it to third parties. And what third parties will do, they will collect these battery packs, okay, and then they will see use case where they can use this battery pack for any other use. So this is what they asked me to develop, and I developed already. We developed already, but still, this is what they ask me for future, okay. But how it is going to help for home use or any other use, I don't know at the moment, okay. But yeah, they are also thinking, okay, how they can try to use the batteries from the car, okay, which are already ended with the battery life. Because if the battery life is shorted, and if we want to trash that battery, there will be lot of batteries, okay, will be there in the market that needs to be destroyed. And anyway, then if we want to destroy the electric battery, then it's going to harm environment. So they're trying, okay, otherwise how they can use it. But ultimately, after a certain period of time, they need to destroy, but at least they want to increase that period, okay.
Thank you, sir.
Yeah. Any other question? Sorry, I took a lot of time, right? From
No, it's okay, Pravin.
okay.
Very nice presentation. So it's now time to vote of thank of our resource person. Dear Pravin, our esteemed person, I would like to express my heartfelt gratitude for enlightening this session you delivered today on secure communication protocol for battery application vehicle to grid communication as a part of our ATAL FDP on next generation communication. Your expertise insight on secure communication protocol have been invaluable, and your presentation has broadened our understanding of the critical role that secure communication plays in battery application vehicle to grid communication. We appreciate the time and efforts you invested in preparing and delivering this informative session. Definitely, your contribution to our FDP has been immense, and we are very thankful for your willingness to share your knowledge with us. So, thank you once again for your inspiring talk and for being an integral part of our FDP. We look forward to future opportunities to learn from you. Thank you very much.
Yeah, thank you so much for inviting me on this session, and I try to deliver the things which I can. Thank you for your attendance and yeah, bearing me for last couple of hours. Thank you.
Okay, now we will start our validity. First of all, we will take some of the feedback from participant side.
So should I stay now or should I disconnect?
Yes. If you want, you can stay.
Maybe I can disconnect then, no problem.
Okay.
No, it's really needed, then I will stay. Otherwise, if it is your
Okay, just if you want, you can stay just for 5-minute function.
okay, no problem. Yeah, then no issues. Thank you.
Now it's a time to give your feedback regarding the FDP, regarding the resource person. Participant can unmute yourself and give your feedback.
Hello, sir.
Yes, sir. Yes, sir.
I am Professor Pansande. So I would like to thank you all and the organizing committee of this FDP for giving me a great opportunity to learn new things. And really, I get a very good knowledge from all the resource person. And thank you once again for all organizing committee and the team and the principal of SVPM COE as well as the co-convener of this FDP, Kale sir.
Thank you, sir. Thank you, sir.
Hello, good evening all.
Good evening, sir.
Myself, Dr. Raghavendra from G3 Engineering College, Mysore, Karnataka State. So I have attended all the 6 days FDP, ATAL FDP, that is Next Generation Communication. I thank to the team and the coordinators and the resource persons. Everyone done very well. They have given very good topics. They have taken good topics and we have learned many things, including 5G, that too practical things from Geo people. Thanks to the team. Thank you once again.
Thank you, sir. Thank you.
Good evening to all of you. I am truly grateful for the opportunity to attend this ATAL FDP workshop. This session were insightful, well structured, and delivered with excellence by all the knowledgeable experts throughout the programs, throughout the FDP. The practical approach, engaging discussion, and hands on learning experience have significantly enriched our understanding and skill set towards the next generation of communication skills. Definitely, the knowledge given during the workshop is very helpful for upcoming our research activity as well as our future approach towards the research. I really congratulate to the coordinator and co-coordinator of this workshop for arranging all the things very nicely. Kaiser has taken all the great efforts during the workshop. He has organized all the things very nicely. All the communication he has done properly. His efforts is very important during the workshop. Everything with such, he has handled everything with such a grace and efficiency that is truly commendable. Thank you for coordinator and co-coordinator for this workshop for great arrangement and support during throughout the FDP. Thanks a lot.
Thank you, sir. Thank you. Yes, participant can unmute yourself and you can express your
Hello,
yes,
am
sir.
I
Yes, sir.
audible?
Yes, yes, yes.
Now, really a fantastic FDP. We, the teachers from our institute, 6 teachers we have registered for this FDP. And every day we have attended very carefully all the sessions. The resource person were of immense talent. Their presentation was very perfect, and it enhances our knowledge base so that it can be utilized in making our teaching learning process more effective. Thank you, all the team members. Thank you, Principal Mukane sir. Thank you very much, Kale sir, for giving us opportunity to be a part of this excellent FDP through this platform. Really, each and every resource person have taken lots of efforts. When I have gone through one of the sessions of Sridhar Raghuraman, when he was attending the session at 1 o'clock from Sydney, still was there for 2 hours, attending all the queries, giving lots of information regarding the topic which he was supposed to introduce. Really, a fantastic efforts on the parts of all the resource person. I, on behalf of our institute, MIT Chhatrapati Sambhajinagar, wish to appreciate the efforts and wish to thank all the resource person for taking lots of efforts for making us comfortable in all the sessions of this FDP. Really wonderful. Thanks, all the team members of your organizing committee. Thank you once again, sir.
Thank you, sir. Thank you.
Yes.
Is anybody want to say some feedback? Yes, Power sir. Are you there? Okay, sir. So now it's my turn to say the vote of thanks. So, respected dignitaries, Dr. Dhananjay Thomre sir, Secretary of SVPM, Dr. S.M. Mukne, Coordinator of this FDP, all the staff members from Department of ENTC, all the staff and faculty members from various institute from the India, esteemed guest, and all organizer team. As we gather to mark the culmination of our online FDP on next generation communication, I am overwhelmed with gratitude and pride. Over the past week, we have witnessed a remarkable convergence of ideas, expertise, and enthusiasm. To our participant, I offer my heartfelt appreciation for your active engagement, insightful questions, and eagerness to learn. Your diverse background and perspectiveness have enriched our discussions, and we are proud to have almost 125 passionate learners from all over India join us on this journey. To our resource person and speakers, I express my deepest gratitude for sharing your knowledge, experiences, and vision with us. Your contribution have been invaluable, and we are indebted to your expertise. To the Department of Electronics and Telecommunication Engineering of SVPM's College of Engineering, Malegaon Bk, Baramati, I offer my sincere appreciation for giving this opportunity or organizing this FDP. Your dedication to fostering the academic excellence and innovation is truly commendable. So, to our technical team, I thank you for tireless efforts in ensuring the seamless education of these online programs. And I am also thankful to Javed sir for arranging the resource person. Also, I am thankful to my coordinator of this FDP, Dr. S.M. Mukne sir, for continuously guiding and motivating me to apply for this FDP and to arrange this FDP. So once again, I am thankful. So as a co-coordinators, with this, this is from my side, and now I will request our FDP coordinator, Dr. Shailendra Kumar Mukne, to express his vote of thanks. Over to you, sir.
Thank you, Kale sir. I would like, just now Kale sir has expressed the vote of thanks to all the experts, also the participants. So as a coordinator, I would like also to express my sincere gratitude to all the experts who have given nice presentations. I was attending all these sessions. Just now, Nagrik sir mentioned that the Sridharan from Sydney, similarly Pramod from Sweden, and other some resource persons were from Europe and America as well. So this is the help which they have extended to make this FDP a success is means there are no words to express gratitude towards them. So at the same time, the participants who have shown faith in our FDP and they registered for this FDP, I would like to offer my sincere gratitude to them as well. And not the least, our co-coordinator, Professor Santosh Kale, he has nicely handled all the sessions, well coordinated sessions, and he was assisted by Javed sir. So hats off to you, Kale sir, for co-coordinating this particular FDP and making this FDP a grand success. Thank you, one and all.
Thank you, sir. Thank you. Lastly,